Well, okay. So just quickly about my person. My name is Petr Klimek, and I'm working in the PV business about 15 years. Out of these 15 years, I'm working for the company SolarEdge, and you may know that we have quite similar development of PV business like in Ukraine. We had a big boom of, let's say, commercial PV plants in 2009, 2010. And then the market was a bit, or went a bit down because we had also a very high green tariff or feed-in tariff. And actually, just after a few years, our PV market is growing up. I see some similarities with the Ukrainian market, and maybe I can share even some experiences with the PV and PV parks built in 2010, 2009. Let's start with also with the company presentation. So I will not talk long about numbers and about who we are, but you just should know that the company was established in 2006, and we started to deliver some first shipments to the market in 2010. And since that time, you can see that we made a big jump. We have almost 3,000 employees. We have very nice financial growth. We are present in the 28 countries. And actually, we became #1 solar inverter company in the world. And this really in a few years. We are working with more than 33,000 installers all over the world. We are present in 28 countries. We have regional service centers, and systems are installed really all over the world. So we are really a worldwide company. Here you can just see where we have our R&D centers. Israel, it's the company, the origin company is in Israel. We have R&D center in Bulgaria, in US, in California. Then I will talk about some other companies we have acquired and are part of the SolarEdge company now. And here we have R&D centers in South Korea and in Italy. And of course, we have some manufacturing facilities, China, Vietnam, Hungary, Korea, and a new established factory in Israel. If you look at the numbers, I mean, in the ranking of the inverter producers, you can see that when I entered the company in 2012, was 8 years ago, it was still, I would say, a bit startup, but the growth was really, really, very quick because SolarEdge, I would say, changed the way how the energy from the sun is managed. So you can see even in 2019, SolarEdge was the #1 company in the world in terms of turnover, and we have beaten even the old, very established brands who were in the market a long time ago before we entered the market. But this is, or let's say, SolarEdge is not just about PV business anymore, but SolarEdge would like to be, let's say, one-stop shop for many smart energy applications. And therefore, we have acquired some other companies in recent years. First one was the company Gamatronic. You may know, maybe you don't know, but it's our UPS division in the company. We are working on some common projects all together. We have acquired the Italian SMRE, which is a company working in EV business and is a provider of innovative integrated powertrain technology and electronics for EV cars. And last but not least is the Kokam. Not sure you know the name. It's a South Korean company, but this is our battery division, I would say. It's really top company in the battery field. Even though you never heard the name, you may check the website and you will see that the Kokam batteries are in many application space, Navy, or in big energy storage systems all around the world. It's quite unique technology. I can really say it's number one in the space or Navy business. These batteries you can find everywhere. For instance, maybe you heard about the solar plane, which was flying around the world. You may know that there were batteries from Kokam. Or if you look at at some military applications, then you can see that there are many batteries, for instance, in F-16s, tanks, submarines, even torpedoes and things like that. So very interesting company, very interesting part of our, let's say, portfolio. And you may check some more details at kokam.com. Why SolarEdge became so successful in a few years? As I already mentioned, SolarEdge changed the way how the energy from sun is being managed. Traditional systems, they have some limitations, and you may probably know that, but we can go through quickly again, and it's good to remind it because it's also related to design rules, which we will discuss later. And I see many mistakes in designs, especially in the PV developing or markets where the PV is being developed quite quickly, and people using the design rules from the traditional inverters and making unnecessary mistakes. So if you look at the PV module, you probably know it has its own IV curve, and there is only one point on the curve by specific voltage and current when the module produces maximum power. This module curve depends, of course, on the individual electrical properties coming from the factory, and also depends on the ambient conditions, especially on the irradiance and a little bit also on the temperature. But if you have, even if you have modules from the same producer on the same pallet, you can be sure that every module is a little bit different. Every module has a little bit different IV curve, and this is something what we call module mismatch. I mean, if the modules having different IV curves, we talk about the module mismatch. And if you look at the standard PV system with traditional old-fashioned inverter, you may know that, just a second, please, that the inverter itself is trying to find the maximum power point for all the modules connected in the PV array or in a specific string. And you may also know that the weakest module is influencing the production of all the other modules in the string. So there might be a lot of reasons why there is a weaker module in the string, but you can be sure that even when you get the new modules from the production, there will be some kind of difference between the modules, and we can say from the scratch there is a 2% in energy production, which you can get more if you are using MPP tracking on the module level. We will talk about it later on, but for you to understand or what to take out of this is that if you have modules with different IV curves, you are losing the power. This is the basic idea from that slide. I will just quickly check the chat because I see there are some comments. Oh, so it's in Ukrainian language, so we will discuss a bit later. Okay. Moving to next slide. Okay, so we were talking about the module mismatch. That means if we have different module curves on the modules, and what are the let's say sources of this mismatch? I already mentioned that you get the modules with the differences already from the factory, so we can talk about manufacturing tolerance. But the most, let's say, popular source of mismatch is, of course, shading. But it's only one of several sources of mismatch. So this is something what you should remember. We will talk about optimizer cliches, I would say, and many times you can hear in the market, okay, your PV plant has no shading, you do not need optimizers. I will explain you in a few slides that this is really false statement because first of all, there is no installation in the world without shading. Even moving clouds are creating a shade and reducing the power output of the plant. And you can have many other resources or sources of the mismatch. Soiling, whatever you put on the module is actually creating a shade. So if it's a dirt, if it's snow, if it's whatever leaves from the trees, and we can talk about the current shading or soiling or future shading and soiling. You never know if at the site where the installation is placed, there will be a new antenna or some pole or some tree or whatever. You know, the situation can be completely different in 5 years than it's now. So soiling, shading, current or future. Then we have a so-called thermal mismatch. If you would ask module producers, they would maybe tell you that the power loss caused by the thermal mismatch could be about 3 to 5%. What does it mean, this thermal mismatch? If you imagine this picture as a PV plant, not as a module, then you can be sure that the heat in the middle of the PV plant would be a bit different compared to the modules which are on the edges of the PV plant. Why? Wind, for instance, is redistributing the heat. So you can probably estimate that these edges would be a bit cooler than you know, the modules in the middle of the plant, and this is also valid for module itself. So even in the module, you can find different places with different temperature, and you may also know that the temperature is not really good for PV because every degree Celsius up means 0.43% reduction of the power. So you can imagine if these modules, which are a bit hotter, are in the site, they can decrease the power output of the cooler modules. So this is shortly said the thermal mismatch. Then of course you have sources like different tilt and orientation. You probably know that with the standard inverter you cannot put modules in a different orientations and tilts. In a standard system, the design of the strings must be completely the same. Another source of mismatch could be transportation damage or installation damage. Please be aware that silicon is really fragile, and you should take care about the modules. Do not walk on the modules, like I saw many times. Even the little vibration on the track or on the boat, if the modules are not really good packed, can create hotspots or microcracks in the cells. And of course, you can do some flash testing of the power in the factory, and you can do some flash testing on the site, and the results can be completely different. So in general, you have many sources of mismatch in practice, and this can lead to power losses. This is something, well, this slide is something I would like to talk about because this is something which I can see in let's say, reality in the Czech Republic. As I mentioned to you, we had a big boom of commercial plants in 2009, 2010. And I was also closely working with one laboratory who, let's say, was accredited for the testing of the modules. And there are many theoretical studies like this one on this slide, or theoretical, even practical, which are showing the degradation of modules. If you look here on the gray columns, so each column represents a batch of modules, PV modules from the same producer. And what they did in Italy, they took about 50 batches of modules and were checking, you know, how the modules are losing the power. You probably know that the modules are, you know, they have some kind of warranty on performance, on power performance. And this should not, you know, be after 20 years below 80% of the nominal power. So this is let's say, some kind of standard you can see on the module data sheets. And this was proved in Italy. So they were testing the 50 batches of modules, and you can see that you know, they didn't lose more than 20% of its nominal power within these 20 years. That's fine. That's very positive. The problem here is that once you have a batch of modules from the same producer, and you look at the modules and the 20 years, you will see that one module is losing, for instance, 13% of its power, but another one only 2% of its nominal power. So what does it mean? If you create a standard system with a standard inverter, you know that the weakest link, weakest module will influence the power output of the other modules in the string. So only one weaker module will affect the production of all the other modules and the PV plant at all. And this is exactly what we see in the monitoring. SolarEdge can provide a module level monitoring, so we can see really the production of each module. And if you take a PV plant and a sunny day after a few years, you can create an easy a graph showing the energy production. So here on this picture, you can see the graph of energy production of one PV plant, of its modules. And you can see that the worst module is producing about 10% less than the best modules. So in an average, there could be a loss of maybe, I don't know, 3, 4, 5%. Because if you would have a standard system, the weakest module will influence the production of all the others. You may not believe this, but there was a study done by one Czech university on one PV park built in 2010, I think. So it was done in 2016, I think. So 6 years of operation. Sorry, this slide is in a Czech language, and of course the study is much longer. But there was a project which was financed by the bank, 80%, and then 20% was the own equity of the owner. But after 3 years, you know, they just recognized that the PV plant is not producing as it was planned. So they asked the university, you know, to check what happened. And you can imagine it's not an easy job if you have thousands of modules on the field, because if you do not have a module level monitoring, you can only check the strings. Maybe you can take some picture from drone or from infra camera, and then maybe you can recognize there might be some issues. But anyway, you need to send people with some equipment on the field. They need to measure the voltage of the string, probably measure the voltage of the module. And if they find some modules are really not performing well, they need to bring it to laboratory and do the testing. And if you look at the price of the testing, it's about 300 to 500 euro, which is obviously more than the new model. So it's really cost expensive solution. How to do, let's say, a module check or a PV plant check after a few years of operation. But they did it, and they really tested hundreds of modules. And what was the conclusion? The conclusion was exactly what we see in the monitoring, that some modules degraded really in a high pace. Some of them were a little bit better, and some of them were almost without the degradation. So that was, you know, the result of this study. And so they found the problem, and now they were trying to find a solution. So what can they do? The recommended solution is to go on site, really take the wrong modules and put them in the same string. So you can imagine this is another crazy thing to do, because we need to send a lot of people on the side and restring the complete plant to have good modules with good modules and bad modules with bad modules. So I didn't talk about it yet, but this is the first advantage of module level monitoring. You don't have to go anywhere. You don't have to buy any expensive equipment. You have all the data about each and every module in the monitoring in your computer. And with 2 clicks in our monitoring, you can do a site analysis, and you can compare the production of modules between each other with the simply 2 clicks in the monitoring. This slide is just the, you know, something you may think of. It's really not any professional slide. It's just, you know, some calculation of losses caused by this degradation of modules. It's very simple illustrative example. It's nothing professional, so I'm not discounting. I'm not using dynamic methods like net present value. I'm only taking into consideration the simple calculation based on 1 megawatt example and some assumptions. So if we take 1 megawatt as an example, and let's say this 1 megawatt produces, or 1 kilowatt produces 1,000 kilowatt hours, then for 1 megawatt, 1% of loss means 10,000 kilowatt hours. And if we just saw that the average loss after a few years, just because of the different pace of degradation of the modules, is about 5%, and this is really conservative number, then you can easily calculate what does it mean for 10 years, 20 years, 30 years, based on the price of kilowatt hour. So you can do your own calculation. Of course, it's always based on how long for how long period you are doing your cash flow calculation. But 1 hour ago, I just saw a nice post from a friend of mine and he was showing the modules after 35 years, which were still producing quite well. So PV is not really an investment for 5 years like a car or whatever, but it's at least for 20 years. The modules can survive 30, 35 years, 40 years maybe. And if you calculate the losses just because of the module degradation, it's a huge amount of money, which can pay, for instance, the cost of the inverters at the beginning, or even more. So this is very simple example, as I said, not discounted. So if I conclude about the traditional systems, once you have an inverter looking for the maximum power point for all the modules connected in the same string, and the modules have different IV curves, you can be sure you are losing the energy. In the standard system, you may have only probably string monitoring, which some companies calling smart. But in my opinion, this was smart maybe 30 years ago. So with the standard monitoring, the modules are not smart, but I would say a bit stupid. So with the standard system, you have low resolution monitoring. There are some design rules with the standard inverters you have to follow, and very often you are limited because now even you will face a lot of rooftop installations. I believe the ground-mounted installations in Ukraine are a bit over, and the market will move to the roofs. And the roof is not the same like the ground. You will see a lot of shading elements on the roofs and things like that. So with the standard systems, you are a bit limited. With the design, with SolarEdge, you can do a lot of things, and we will talk about it a few slides later. And safety topic maybe not so discussed in Ukraine yet, but in the whole Europe, it's a very strong topic. And I can tell you that the integrated safety functions included in our system, which we will talk about, will help you to sell PV in the future years. And you will see that this kind of topics will come to Ukraine very soon too. So if we do a quick overview about the systems which we have in the market and compare, the advantages and disadvantages. So first of all, we have a standard traditional string inverters. This is the standard system. We have one central inverter. We have modules without any optimization, and also with no module level intelligence, of course. You know that you are losing energy, or the investor is losing energy. You are limited with the design and with the roof usage, and you have no module level monitoring, and there could be some safety hazards in the end. Then we have micro inverters. I'm not sure. There are many producers offering this solution in Ukrainian market, but what you should know, there is no central inverter on the wall, the box Just a second, I think the presentation stopped, okay. But the inverter is very close to module, so it's located on the roof, very close to module. And this solution overcomes many disadvantages of the standard traditional string inverters, but it has a bit limited scalability. It's quite expensive, and in addition, the reliability is a bit questionable, because you can imagine if you put inverter on a hot roof and there are moving components or standard components, I'm not really sure if it can survive 10 or 20 years, but it's a questionable issue. And then we have a combination, let's say, of traditional string inverters and microinverters, and that is something what we call DC optimizers, and this is something what was invented by the SolarEdge company, and why is the company so successful. So Actually, we have the box, the inverter on the wall or on the construction, but we have also so-called DC optimizers. It is still one inverter. So this optimizer plus this inverter is still one product. It's still one inverter. And I have many questions coming if the inverter can work without the optimizer. No. I will explain you in a few slides later that we just divided some functions from the standard inverter, and we move the functions to the optimizer. So this DC optimized solution has one simplified central inverter taking care only about the DC AC conversion, and then we have an optimizer doing the module level optimization, etc. So getting back to this functions moving. This is actually a standard inverter, as you know. So this inverter makes the DC AC conversion and also the MPP tracking. So the inverter is looking for the maximum power point of the modules connected. And what we did in SolarEdge is that we have just divided this standard inverter into two parts. Power optimizer, we will talk about it, what is it in a second, and the simplified inverter, which is doing only the DC AC conversion. Plus, we have added one more important thing, which allows us really design flexibility, and it's so-called fixed string voltage. We will talk about the design and how it works later on, but you should remember for now that we have in a single phase system, the fixed string voltage about 380 volts. And in a three phase systems, it's about 750 volts. If we look at the solution, how we differs. As I mentioned, we are not looking for the maximum power point for the whole bench of modules, but because we have this power optimizer, we are tracking the maximum power point for each module or for, let's say, two modules connected. And the simplified inverter, you can see two types of the inverter on the picture, is only responsible for DC AC conversion. So what is this power optimizer? Power optimizer is a DC-DC converter, which can increase and decrease the voltage. Some other producers or power optimizers, they have only option to decrease the voltage, so they are not so efficient. But we have a buck boost technology, so decrease and increase. And it provides you the feedback on the module performance. It is responsible also for one safety function we will talk about a bit later. And you should remember that it has 25 years warranty as a standard. So as I mentioned, it's still part of the inverter, and the standard warranty is already for 25 years. If we look at the inverter, on the left side, on the picture, you can see a standard three-phase inverter. As I mentioned, this inverter works with the fixed voltage, is responsible for DC to AC conversion, and is really simple. It's really simplified inverter. That's why we can afford to provide it with the 12 years warranty as a standard. This warranty can be extended to 20 or 25 years. You can find it on the webpage. What is the price? I can show you later on where to find it and how to check your warranty. And please be aware that the warranty is really, really important if you are calculating the cash flow or the return of investment of your project, no matter if it's a residential or a commercial project. Because you probably know that the inverter will die during the lifetime at least one time. If you consider the modules will survive on the roof 35 years, then you can be sure that the inverter will die at least 2 times or even 3 times during this period. So if you are calculating cash flow of your project, you should definitely calculate either the money for the inverter exchange or the extended warranty. And if you compare the warranties, then you will see that our warranty is really almost 3 times cheaper than by the competitors. If you are buying the extended warranty by the competitors, you are almost buying a new inverter. So you can easily check the offers, and now you know why the extended warranty is so expensive. You can be sure modules will survive, but the inverter you will probably change at least 1 time per project lifetime. This was a standard 3-phase inverter. We have, of course, a 3-phase inverter for residential. We will talk about it later, and also for commercial projects. But we have also quite unique single-phase technology. I know Ukraine is a 3-phase market, so I will not talk about the single-phase inverters today, but at least you should know that we have quite unique technology, which is called HD wave. So this inverter differs from any other inverter in the market. It's completely new technology based on a bit different components compared to standard inverters. And this inverter has the highest efficiency in the world. It's, I think, 99.3 as a peak efficiency and 99% the weighted efficiency. So it's very small, lightweight, and easy to install. We have different versions of this inverter with the integrated EV charger or with the integrated interface for the battery. It's quite a unique product, and we have been awarded several times at Intersolar or in US for this new technology. But if you are interested, we can do a special session and I can tell you more about it. But as the Ukraine market is a 3-phase, we will focus today on a 3-phase solution. And you know, we talked about the power optimizer, about the inverters, and the integral part of the solution is, of course, the monitoring platform. We will provide you with the module level performance 25 years for free. So it gives you a lot of advantages we can talk later about. So you can see the module performance, you can get alerts when then there is something wrong in the system, and you can easily access this monitoring from your mobile phone or from a computer or any other smart device. Just really a few words about this one-stop shop. I told you that the SolarEdge is really a company who wants to provide a complete solution for the customers. So not even that we are producing the inverters and the power optimizers, we also offering our smart modules. We are having inverters with integrating EV charger. Unfortunately, it's only single phase, so not really valid for a Ukrainian market. We have some solutions for, let's say, home automation and how to manage the energy in the house. So we can heat the water in a smart way. We can have some smart sockets and relays, for other devices in the house. And of course, these smart products are connected to our monitoring, and you can program them. You can schedule different profiles, etc. I mentioned already that we have our own battery division, and this will be a big advantage for the future years because battery is a game changer. And what we see, if we see any issues, for instance, what I see here is the compatibility between the products. And when you have one producer of the inverter and the second one is producing the battery, of course, there must be a good cooperation to have a good firmware that it can work together, and it should reflect all the changes which are coming during the time. So we see quite many issues in that, and that's why we will have our own battery, and we will provide you with one solution, with one firmware, to have no issues in the future. Of course, we have our UPS division, and we are also working on projects in the EV field in Italy. We have a lot of software, and it's not only about monitoring. I will show you some applications in a very quick overview later on, but we have even also software code for grid services, but this is maybe for another topic. I will skip these slides showing the residential and commercial solution, or maybe I will skip just the residential solution, but let's have a look on the commercial, because we will talk about today about the new inverters in the size of 30 kilowatt. As I'm informed, in Ukraine, you have the limit for residential system up to 30 kilowatt, and with this you can use optimizers when you can have one optimizer for 2 modules. So we will talk about it a bit later on, what kind of optimizers we have, how it can be designed, how it can be connected, what kind of inverters you can use with that. We have many more other products, but I will advise you to a recorded webinar from yesterday, where Jason was presenting this kind of products a bit more in detail. Grid services, as I said, we have a lot of projects with utilities all around the world. It's a future of energy systems in the whole world. Our products are demand response ready, so we can work as an aggregator, collect the data about our systems, not only about our systems, and help maybe to manage some areas and the energy flow in the area. We can regulate the frequency, etc. But this is again something what requires additional time and another webinar maybe. Benefits. This is something what you should know when you are offering the SolarEdge system. So we will go through very quickly through of all of them, and I'll explain you why we are producing the most energy in the world at the moment, why we have a lower operation and maintenance cost. I will explain you or tell you something about the safety and our integrated safety functions, and we will also talk about the flexible design of SolarEdge technology. So more energy in all scenarios. As I already mentioned, with SolarEdge, you have optimizer, and optimizers taking care about the module, about the highest production of each and every module independently. So I think this is quite clear picture on the right side. We already discussed this, and it's proved that the SolarEdge system produces the most energy in the world. This is how does it, at the moment, based on the tests which were provided and which we know. As I already mentioned, there are some differences between SolarEdge and between the standard inverter technology. This is how it looks like in the practice. If you have one weaker module, of course, the module will produce a bit less power, but the other modules are not affected, producing full power. When you have a typical standard inverter system, one affected module may decrease the production of all the others connected in the same string. And what can happen here is that either the bypass diodes can be activated and 1/3, 2/3, or the whole module is not working, or very often the module or the bypass diodes are not activated, and that means that this module can become actually a power source, and the current must be reduced in the whole string. In a standard system, the current must be the same in the whole string, and that's why the other modules will produce less energy. We already talked about the sources of mismatch. I will skip this. If you do not believe what I'm here talking about, you can check on the web many tests provided by independent bodies. I have only one slide here, but I can show you some more. We have the results from the laboratory, from US laboratory, when they were testing, you know, all the inverter types. But here you can see the very first test done in 2011 already. It was done by the magazine Photon or its laboratories in Germany. And they were comparing the traditional leading inverter in the market and the system with the optimizers in the different scenarios. So there was a system completely unshaded. Then they at the dormer or the window, then they were testing the horizontal shading, the shading with the pole, and the shading with the, let's say, the situation with the reduced irradiance. Please be aware that this was done in laboratory conditions. So you can imagine laboratory is something different when you install, you know, the system outside. There are many more, you know, things which can affect, you know, the system production. But even here in the laboratory, it was confirmed that even there is no shade, you have 2% added yield for SolarEdge, just because of the inherent module mismatch. So even when you get the modules from the factory, you can be sure you will get 2% more from SolarEdge system than with any other standard inverter in the market. So even if you have no shading, no aging, you are not taking into account any other sources of mismatch, 2% is, let's say, some kind of base you can calculate with for sure. But this is not only, let's say, the more energy is not just about the I would say physical production, but as I mentioned to you, your business is moving more to roofs now. And if you look at the roofs, you have many shading elements. And with the standard systems, you are very limited with the design. You have to shade, you have to avoid the shaded areas. You need to create the strings with the same length. You need to put modules in the same orientations and the same inclination and things like that. So if you look at this slide and the picture below, then you will see a roof where with the standard inverter you can design only 312 kilowatts, but with the SolarEdge system you can add 27% more power. So you can build actually a 39 or 396 kilowatt peak on this roof. And this is quite important. I'm working on many commercial projects, for instance, in many countries in Europe, and I can tell you there are many production facilities, and they are happy for any kilowatt hour produced. So they have a big consumption, and the more energy they can produce, the better. And of course, for you as an installer, is great when you can sell more components, because every component, every module is a certain profit for you. Many times when I'm talking with the installers in the market and they don't know much about optimizers using the old technologies, you can see many, I would call it optimizer cliche. There are many of them. I just put here 3 of them, maybe just, you know, to think about it. And the first one is typical what our competitors are saying. They are going to customers and saying, hey, you have no shade on the installations. You don't need optimizers. I already showed you a lot of slides that the modules are degrading, that you never know there will be a shade in the future, that there are other sources of mismatch, dirt, snow, whatever you can find on the modules. So this is a completely false statement, because there is no installations in the world without the shading. And optimizers, they do not have only the power optimization functions, but there are more functions which are very important for the owner. Let's say the safety functions we will discuss later on. So this is something I hope you understand. This statement is really false. Another one could be that the owner should put optimizers only on the shaded modules. It's called selective deployment, or it has another names. I think I explained enough why this will not help, because one day you have shaded this module, but in 2 years there could be completely other shade coming from a new antenna or whatever. Some module can degrade a bit faster than the others, etc. So again, the same statement, which is a bit false. And in addition, once we will talk about the safety function, if you do not equip all the modules with the optimizers, the safety functions will obviously not work. So this is another reason. We'll talk about the safety later on, but I want you to think about this third optimizer cliche I put here. And you can see this kind of messages coming from our competitors. I found a nice picture showing, and then the competitor is claiming that if you have power optimizers, you have more DC connections, and it's actually dangerous. So this is the statement coming from the market. I will show you why this is not true in a few slides later. Module level monitoring. So we talked about the highest energy yield. That was the first advantage. Now we are going to talk about module level monitoring. I already mentioned to you, we have module level monitoring for free for 25 years. I also mentioned some advantages based on the experience from the real solar parks built in here in the Czech Republic. So you know how expensive and time consuming is to check the installation after a few years if you do not have module level monitoring. You need to actually go on site if you are suspicious that there is a problem, and you are actually looking for the problem. But with SolarEdge, we say no before you go, because you have everything in your computer, and when there is a problem, you already know about it. So you don't have to go on site, climb the roof, measure the voltage, buy some equipment or whatever, but you know the problem. If there is something wrong, you go on site only once, change the component or do the maintenance, but you don't have to go there a second time, with the new component or whatever. So you will save a lot of time and cost on equipment, on money, on people, let's say, work. So with the module level monitoring, you have a detailed analysis of the system, and the owner knows 100% that the system is really working, because with the standard monitoring and with no detailed, let's say, analysis, you don't know if it's just bad weather or the system is not performing 100%. Yeah, so there are some advantages for the installer. And I think installers are doing usually the service for the customers. So for the future years, it's quite a big benefit. And there are, of course, some advantages for the end customers. We may go later on into the monitoring, and you may see what kind of features we have and what kind of reports and analysis we can do. But basically, if I don't know if you know our system or if you installed already our solution, but you will see all your installations in the list, and you can manage them as a fleet. So you can monitor the entire installed base. You can even create reports for all the installations at once, etc. Of course, here is the slide showing you if there is any problem on the site, you will see it on the virtual site map, or you will get a notification through email that there is something wrong on the site. And by the way, we have now changed the alert system. So, and we are in a transition phase. So some of you may see, I think on the new installation, you will see the new alert systems. On the old systems, there is still the old system, but we don't have time to talk about it in detail. But just information for you, there are, let's say there is more flexibility how you can manage your sites. You can create profiles for commercial sites, profiles for residential sites. You can create your own rules when you want to be highlighted there is a problem with which severity, etc. So we have a new application note. If somebody interested in it, I can send later on. One example of a failure and how you can check, for instance, in the monitoring. By the way, this shows the broken bypass diode. And I can tell you from my experience from the solar parks, it was a typical problem on many module types from 2010, 2011. So many diodes were broken, and the production of the system went down. What you can do in the monitoring with the 2 clicks, you can do some analysis showing you module mismatch, and if you find some modules which are not performing well, or you don't get, for instance, the alert from the system, which obviously should not happen, but anyway, you can do the analysis, and then you can do concrete graphs of concrete modules in the monitoring. And this is one example of one issue here. You can see some modules and a graph of a voltage, some modules showing good voltage and one lower voltage, probably 1/3 lower. And if you have 1/3 lower voltage, you may probably know that this was caused by a broken bypass diode. This is just one example. We can discuss more examples with PID, how easy is to find, the PID problems on the site, but this would require a little bit more time. So we talked about the higher yield. We talked about advantages of module level monitoring. Now we will talk about the flexibility of the design and how you can sell more modules than with the traditional system. So we will talk about the design rules a bit later, but you should understand that we can do a little bit different things when you design the system. In a standard system, the all string must be the same length. This is not valid for SolarEdge. You can do parallel strings on an equal length. You can put modules in multiple orientations in one string. You can even use different modules from different module producers in the same string. You can see on the picture here. This is quite a nice feature. Because you can imagine, I'm getting back to this Czech solar parks from 2010. These were built with the modules of 200, 220 watts, for instance. And some of them are broken or are down. And now it's very tricky to find a 220 watt module in the market. So it will be very tricky to put a new 300 or 400 watt module in the same string. Probably you can do it, but you will definitely not get 400 watts out of this new module because the weakest link in these modules will influence the the production of all the others. What is different to SolarEdge, because the optimizers are backwards compatible. So if you have some older optimizers here with the older modules, you can put here a new module with the new optimizer, and you get always the maximum power of the module because these modules are working independently. Longer strings, of course, when you see the inverter cover, and we will see it a bit later, you may see we have only 3 or maximum 4 inputs for DC strings. This is why, well, the reason is that we can do very, very long strings compared to standard technology. I already mentioned to you that we are working with fixed voltage, and this fixed voltage allows us to do even strings with 60 modules in one string. If compared to a standard traditional system, 1000-volt system, you can probably put 20 to 22 modules maximum. If you have a 1500 volt technology, then probably a bit more. But with our system, you can do much longer strings. And of course, you are saving cabling, you are saving connections, combiner boxes, and other balance of system components. Some examples. If you have a house and you can see a dormer on this house, with the standard systems, you have to avoid the shading areas. So you can do a project with total of 8 modules. I don't think this house looks nice if you have only a part of the roof covered by the solar modules, but with SolarEdge, you can do it. Of course, the production will be a bit limited, but the shade is moving and is not the whole day on the module, so it will be still nice production. You can sell 6 modules per project more, and as I mentioned to you, every module means a profit for you, so you can sell more modules than with the standard system. The owner has higher production, and the installer has a bit higher profit. Another example, if you have 2 roof facets, probably with the standard inverter, you can equip the modules only with only on this side. Here, maybe you can put 4 modules. Maybe some inverters can manage that, but with very, very bad efficiency, because the voltage would not be enough for the inverter to operate in the MPP range, and there must be some DC-DC converter inside the inverter who will increase the voltage again. So very difficult to design with the standard technology. But with SolarEdge, quite easy. You can put all the modules in one string. By the way, the longer strings you do, the better, because of voltage, because of savings. We will talk about it later, but this is just preliminary for you. The longer strings, the better. I see many times, by so many times, installers creating 2 strings, which is useless when they can do 1. If they follow the basic design rules, it's better to do 1 string than 2. Safety. Well, as I mentioned, this topic is maybe not so discussed in Ukraine, but I see the first projects and first international companies who are really, even in Ukraine, focused on this topic. So if we are talking about PV is safe. We have millions of installations around the world, and basically PV is safe for people and the assets. But the more installations we have, and the more, let's say, the installations are older, then we see that there are some issues with fires initiated by PV or with fires in general. And when you have PV on the roof, it can be a bit complicated for firefighters or even for maintenance staff to deal with it. So safety functions are really now being discussed in Europe, and also required by many insurance companies already. So if you want to protect the people and the asset of the owner, you should think about the technology which provides some safety functions. We can talk about the module level shutdown, we can talk about the heat detection, arc fault detection and interruption, module level monitoring and things like that. It would take us maybe an hour, but I would just like to mention maybe two main integrated functions in the SolarEdge technology. But first, to understand why the standard system can be potentially dangerous. If you have a standard system with the inverter, let's say here, and the cabling to the modules, whenever you turn off the inverter or you turn off the AC side, then you can be sure that you can cut off the current, but the voltage in the cabling can be still 1,600 or even 1,500 volts. The technology allows us. So this can be potentially dangerous for maintenance staff and for firefighters when there is a fire on the roof. What the firefighters usually do, of course, when there is a fire, they cut off the AC power. So they want to reduce the risk of being injured by electricity. So when again, when you have a conventional or traditional systems, when you turn off the AC or turn off the inverter, you shut down the current, but you still have high DC voltage. Solar modules and cabling is still energized and can be dangerous when there is a daylight. We have tested this in the Czech Republic, and there was a fire on the roof with the modules, and we expected that the steam and the dust and will cover let's say the modules, and the voltage will be low, but it was still about 600 volts. So when there is a daylight, the modules are still operating, no matter the house is burning. And if there is additional fault, for instance, the conductor broken, it can even energize the construction. So it can be also dangerous for firefighters. In many countries, they are using DC isolators or DC switches. They put it either close to the inverter, or they put it on the roof or on the wall, so they can easily switch the DC side. But again, they only switch, let's say, the current, but the voltage stays. And in addition, these electromechanical switches has to be maintained. They need to be switched off and on several times per year. Otherwise, there could be an oxygen layer on the contacts, and this can create an electric arc, which can be a source of fire. So even though this should be a safe switch, if you look at the web page and you check, for instance, the Australian experience with the DC isolators, you will see that many of the fires which happen in Australia was actually caused by this kind of DC isolators. So to have an electromechanical switch on the PV installation can be an issue if not correctly maintained all the time. When you compare to a SolarEdge system, I'm not sure if there is a proper slide, but we have an automatic function which is integrated and which puts the system in a low voltage status, I would call it. So once the firefighters cut off the AC, or I think it's written here on the slide, once the AC power is off, or you switch the inverter, or there is any damage on the conductor, for instance, there is a water because of flooding, or the animal cut the wire, or there is a big heat, and the conductor is damaged, then this system automatically goes to so-called safety mode. What does it mean? It means that every optimizer produces just 1 volt. And if you have, let's say 50 or even 60, 60 is not so typical, but if you have 50 volts or 50 modules in the string, then you can be sure you have only 50 volts DC, and this is a safe voltage. So this function is fully integrated in the solution, is for free, and is certified. So Safe DC has a certification as a DC disconnect. So when you are using SolarEdge, you don't need to install any hardware DC switches unless it requires, from some, for me, unknown reason, the legislation. In some countries, it's required by the legislation. But as I told you, DC switch can be a problem if not correctly maintained. So this is the first function which can enable for you as an installer, because even when you are installing the system is in the safety mode before you activate the optimizers. Before you connect the string to the inverter, the optimizers are producing 1 volt, so you can be sure that you will be not harmed by on the roof and when you are installing. So for installers, for maintenance stuff, or for emergency situations, this function is fully automatic and integrated in the solution. Why, let's say we have this 1 volt? Sometimes you can even measure the voltage. Of course, if you go and measure the voltage on the system and you measure 400 volts, then you know it's probably dangerous. So everybody should be aware of this. But sometimes you can do a measurement on the conventional system, or when using some electromechanical switch or a fire DC switch. It's also popular. Then you can measure 0 volt. But is it really safe in terms of voltage? What if there is a conductor broken? There could be still 400 volts, but you measure in the end only 0 volt. So conventional system can be quite unsafe. But when you have our solution, you know, when you measure 30 volts, that the safety function is working, and really every optimizer is producing 1 volt. That was the first function. We call it Safe DC or Safe Voltage. Another one, which is now being discussed and required by many companies. I can tell you, I'm doing projects for very big international companies, and if you look at the tenders, or if you look at their internal presentations, they usually ask for electric arc protection. Electric arc. What is electric arc? It's actually ongoing high energy discharge going through normally non-conductive media such as air. So if we talk about fires and PV, 90% roughly estimated is caused by an electric arc. So that's even the reason why the companies are asking for this function. Because they want to protect, first of all, the assets and the people inside. Why not to have safety functions on the PV system when it's possible? It can be integrated part of the solution, like we have in the SolarEdge system, or it can be done also externally. here we can see the picture of the arc and what these arcs are doing. Of course, arcs are generating heat, and heat can create a fire. If you look at the internet and check, what are the typical sources of fire or problems, then you will see it's either bad installation work. So there are some loose connections between the connectors, or there are improperly connected cables. There could be some corrosion, or animals can do some job on the cabling. I mentioned already the DC isolators. In addition, when you have a new system, everything is working fine, but after some years, not only modules are degrading, but even the cables, connectors, especially when they are under sun or under unpleasant weather conditions, you can be sure that the arc risk is increasing, but is of course still low. And now we are getting to this point when we will talk about components. As I mentioned to you, this electric arc detection and interruption can be done either externally or can be part of the systems. So in some systems you can find this function. By some producers of inverters, you have to do this function externally. It's possible, but of course it costs more money, and there could be some issues with the compatibility. There is probably no compatibility with the monitoring of the system and things like that. SolarEdge has this function, of course, integrated at no extra cost, and you will get, of course, some messages in the monitoring. We are certified according to US norm, which is called UL 1699B. Why the US norm? Because the European norm is still being prepared. It's not ready yet. So if you look at the tenders of many international companies, you'll probably find this American norm in the tender. And this brings me back to this optimizer cliche. As I told you, some people think that if you have optimized system, you have more connections, and it's more dangerous for the installations in terms of fire initiation. I try to find now one document which I found, and I will try to share it with you. That's the one. I hope you can see it. And here you can see system with the optimizer. You can see that there are really more connections in the system. And here is the standard system, standard inverter. And the competitor claims that this system is more dangerous than a standard inverter system. In general, it's true, because you have really more connections here. And as I told you, the more connections you have, it can be potentially dangerous. But the competitor is not saying the B of the he says A, but he doesn't say the B. That means that this system, for instance, SolarEdge system, has the integrated electric arc protection function. So you cannot reduce the number of components all the time. Yeah, the less components you have, of course, the less is the danger. But the systems are getting bigger and bigger and smarter. So you need to create also the smarter functions that you can create the systems bigger. So this is definitely something which is really confusing for many people. Forget about this. If the inverter has the electric arc protection functions, you can think that this statement is not really true. Okay, I'm sorry, but it went back to some slides. Okay, so that was a short introduction of two safety functions we have. We can talk more about safety. We can talk about cybersecurity because we have a cybersecurity software, and we are asking, you may check on our webpage, we are asking for help. This is one topic actually very interesting, especially for Ukraine, because if you visited our virtual solar show, there was a presentation from Mayor Adest, one of the founders, and he was talking about the cyber attacks in Kiev, and that there were some attacks, you know, and the Kiev was without electricity. So quite interesting topic, what you can do today when the energy system is not really protected. We can talk about also about the data. For instance, if you have Chinese inverters, there is a law in China that all the companies have to provide the data to the Chinese government. The Chinese government can also block the internet connection between China and the rest of the world. It happened already. You may check on the Google. So there are many things to be considered when we are talking about the safety. Not only about the hardware, it's also about the software issues. What we are doing, we always focus on safety. So we are preparing some new features, and for the next coming inverters, we are adding surge protection devices for communication, for DC, for AC. With the new synergy, that means the bigger commercial inverters, we will have even thermal sensors on the DC AC terminals block that we can measure the temperature there, and you know, have some information before any problem even occur. And there will be some changes in the optimizer as well, but we will talk about it in some next sessions. So if I conclude, if you use a standard system, it has some safety drawbacks. You can read these kind of things a bit later on. I will not repeat them. If you use DC optimized systems, and especially the SolarEdge systems, you have some functions integrated and for free. This can help you when you are selling these systems, because it's protecting the people, it's protecting the asset, so the buildings of the owner. And as I said, from my experience, if you look at the many international companies, especially when we talk about public buildings or supermarkets, they are really preferring safe systems. Even their insurance companies, where they see the increased number of fire, they are pushing these companies to have safe solutions. And there are even some insurance companies creating recommendations to use DC power optimizers or microinverters, for instance. This is just one funny picture for you. A question for you: what's really more safe? Is it the system with the fewer components, or really the smart energy system with more components? You should really think about it. So if we talk about safety functions, I mentioned safe DC. Maybe just for information, for your information, in United States, the regulation is a bit more strict. You need to discharge, you need to make the voltage low very fast. So they require 30 volts within 30 seconds. Safe DC, of course, reduces the voltage, but it takes about 3 minutes to 5 minutes, you know, when the capacitors are discharged. So it's a safe function, but it takes more time a little bit. Rapid shutdown in US, we of course comply with the US versions of our inverters on that. You need to reduce the voltage to 30 volts within 30 seconds. In some inverters, in European inverters, you can have this function as well. But from my understanding, in many countries, the safe DC is absolutely enough. Arc fault detection was mentioned. And of course, monitoring will be a big part of these safety features, because you can get alerts on issues happening on the site. If we talk about the SolarEdge and the traditional systems, you should decide what you would like to offer to the market. Either you will offer the cheap standard solutions and you will fight for every euro, because normally the cheaper offer wins in many cases. But actually, what's going to happen after a few years when you are selling only the cheap systems with no real values, you will probably not earn enough money to develop, to do the service, etc. So I would not recommend really to focus on cheap products, because in the end, and you will see after years, the cheap systems might be very expensive. So with SolarEdge, you can have a system with some real added values. First of all, you can sell more modules, because you can use the design of the roof fully. You will save money on the cabling, combiner boxes, connections, etc., because you are not creating so many strings like in the standard systems. Even the DC connection is better, and in terms of commercial projects, we can save a lot of money. You will save a lot of money on a system design. It's easy to design, and I hope we will get to this designer program later on, and I can show you how it works. At least we can do some basic design. You can guarantee your customer that the system is 100% working, and you can offer proactive maintenance, because you have all the data about the system in your computer. You don't have to go on site. You will get the info when there is a problem all the time in your via email, or you will see it in the monitoring on the map. Future storage requirements, of course, our systems will be ready with our battery, and this is topic maybe we can discuss a bit later. We have already some products which are compatible with batteries, some will be compatible, and some new coming will be compatible even with our new commercial battery. We will talk a bit later. Of course, you can manage your fleet of installations very easily, and you have all the alerts in email or on the virtual map. So there are these kind of advantages, safety advantages, and of course, the highest production and the quickest return of investment. If you look at the simple diagram here, comparing the traditional system and the SolarEdge system, it's very simple graph. We can, if we would have time, we can go into deeper analysis, into Excel file, and we can calculate the cost of the inverter per lifetime. But we can maybe do later. Here, you just need to compare the basic stuff. So if you look at the traditional inverter and the BOS costs, BOS means balance of the system cost. That means the cabling, combiner boxes, MC4 connectors, and things like that. As I mentioned, you do less strings with the SolarEdge system, because we can do very long strings. So that's why you are saving money on these BOS components of the system. If you look at the inverter exchange, I told you the inverter will die one time or maybe 3 times, depending on the lifetime you calculate. And you really need to calculate either with the money in some reserve fund for the inverter exchange, or you buy the extended warranty. I told you SolarEdge have 12 years warranty as a standard and 25 years for optimizers as a standard. And you can very cheap, or the extension of the extended warranty for 20 or 25 years is very cheap. So you can compare the inverter replacement cost very easily with the traditional inverters, and you will see we are much cheaper than a standard technology. We can talk about the operation and maintenance cost. I already mentioned how costly it is to check the modules on the side and do all the stuff. So you can be sure you will save some money on operation and maintenance cost if compared to traditional inverters. And of course, we can compare also the yield that you can produce. You can use some independent programs like PVSol, PVSys, the independent Swiss programs, and they will always tell you that with SolarEdge and the optimizers, you will get more kilowatt hours than with the standard system. So overall, even though the system looks like a bit more expensive at the beginning, if you really think about PV as an investment, long-term investment, at least for 20 years, you will see that the lifetime value of the DC optimized system is higher than when you are using even the cheap Asia technologies. So this was about, let's say, the sales advantages and the differences between the traditional and inverters and SolarEdge technology. And now I will try to guide you through the products, at least the basic ones, because we don't have time to go through all the products we have. So first, we will talk about the power optimizers, and we will also touch the design rules when we are talking about the power optimizers. So first, power optimizers for single-phase inverters and three-phase residential inverters. That means, in this case, you are using one optimizer for one module. This is valid for the inverters up to 15 kilowatt. When you have inverters 15 kilowatt and above, you can use one optimizer for two modules. Yeah, but up to 15 kilowatt, the combination is 1-to-1. I will show you later on a data sheet, but basically we are talking about optimizers which are named P401 up to P505. There are some older optimizers in the market, but the module world is changing very fast. So we are removing some versions of optimizers from the price list. You can still find them on the market, but officially we are producing only the optimizers which will be on the datasheet later on. So what is this power optimizer? As I mentioned, it's a DC-DC converter optimizing the production of the module, and is located either somewhere close to the module, typically on the construction, or we have even the versions which can be mounted on the frame of the module. Please, it's a bit special bracket here. Don't drill the holes to the module frame, because you may lose the warranty of the module if you do it. So please don't do that. We have, I believe, optimizers for almost all modules in the market. Some of them are not covered because there are some new versions of 550 watt modules or whatever, which are announced, which will come into the market. But we will have to adapt to these sizes. We have optimizers for bifacial modules and other high powers modules as well. Of course, the optimizer has the 25 years warranty, is responsible for the maximum production, for the safety function, for the safe DC. And if you look at the types, you can see them here. You can see, for instance, here optimizer P370, We just announced that we have stopped the production of this optimizer because the modules are getting bigger, and the standard basic optimizer will be the optimizer P401, which is, let's say, up to 400 watt and up to the current of 11.75 amps. Of course, there are some other optimizers as well. Usually, the number represented the maximum power, but it's not valid anymore because if you look at this optimizer's 370, normally we would say, okay, it's for modules up to 370 watts. But it's not true anymore because the new modules coming with the M6 cells inside, they have a little bit higher current. So you can have a module of 340 watts, but the module current can be above 11 amps, and therefore you cannot use it. So the simple rule from the past is not valid anymore. You need to check really the module characteristics and choose the right optimizer, or you will use the program, and this program will choose the right optimizer for you. We will come back to that later on. So this is the, let's say, the most popular optimizer now. It's P401, and here you can see some screenshots from the data sheets showing you some important figures and numbers. Because here we can even start with the design rules. If you look at the bottom of the data sheet, you will see the design rules here below. But please be aware, I call it so-called STC design rules. STC means standard test conditions. So in these conditions, you calculate that the 300 watt module will really gives you 300 watt because it's in the laboratory in some optimal conditions. But in reality, you know that 300 watt module will never give you 300 watt, or maybe it can happen 1 time, 2 times per year when the conditions are optimal. Yeah, but usually you don't have the module in the optimal inclination or orientation, so you should be aware of this. But these rules which are here and which I will shortly describe are calculating with the STC parameters. So actually we have 2 basic rules in SolarEdge. It is the minimum number of modules of optimizers and the maximum string length or the maximum power per string. Yeah. I will focus here on the 3-phase residential because single phase is not really something interesting maybe for Ukraine. So if we talk about the 3-phase small inverters, that means the inverter from, let's say, 4 or 5 kilowatt up to 12.5 kilowatt, then you should be aware that the minimum of optimizers is 16 or 14. It's 16 for this type of optimizers, P370, P401, P500, and 14 for the rest of the optimizers. Why is like that? I told you that the fixed string voltage is about 750 volts. And maybe I will jump into the full data sheet because there is one parameter missing which I want to show you. So I hope you can see it. So if you look at the parameters, you can see the maximum input voltage or MPP operating range. You can see the maximum current, for the optimizer, but you can see also the maximum output voltage. So you can see for every optimizer, the output voltage can be a bit different. Yeah. So the optimizer needs, for instance, 8 volts, and it can increase, because it's DC-DC optimizer, it can increase the voltage up to 60 volts in case of P401, for instance, or it can increase the voltage up to 85 volts in case of these optimizers. And as I mentioned to you, in the three-phase systems, the fixed voltage is about 750 volts. So how many optimizers do you need to reach 750 volts? Of course, you will need less number of optimizers if the optimizers can increase the voltage up to 85 compared to the optimizers which can increase the voltage to 60. So if I go back to the just a second, sorry. No, it's not the right presentation. I do apologize. Now it's the right one. So if I go back here and you see that I need 16 optimizers to have this 750 voltage, or 14 optimizers to have this 750 volt. This voltage is of course needed for the system to operate. Yeah. If you calculate it properly, you will find out you may need only 15 or 13 to get the required voltage. But first of all, the systems need a little bit high voltage in the beginning to start the operation. And second, some module can be shaded, for instance, or some modules can be shaded. So we have always a reserve when we require you to have the minimum of the optimizers in the string, yeah, for the system to start to operate. And of course, you can combine the optimizers in the string, but always only the optimizers in the same row. Why? Because these optimizers can increase the voltage at the same level. So these can increase the voltage to 85 volts and these to 60 volts. We will come back to this, how the optimizers are working a few slides later when we will talk about the concept of operation. For you now, please just remember there is a minimum of optimizers or modules for the system to operate, and there is a maximum number of optimizers or modules, or the maximum power per string. If you look at the maximum power, basically, with some exceptions, when you can do more, it's 11.25 kilowatt. And you can easily check how many modules you can put in the string if you divide 11.25 by 330 kilowatt, 330 watt or 300 watt. Yeah, so you can see that you can do 35, 40 modules in the string. But we will come back to this a bit later on again. Power optimizers for commercial systems. So here we will talk about 1 to 2 solution, 1 optimizers for 2 modules. Here you can see on the picture how does it look like. The modules are usually connected in series together, but we have also some optimizers when you have more output cables here, and you can connect 2 modules in parallel to the optimizer. But it's only actually 1 optimizer called P800P, typically used for instance, some power modules and special modules like that. But otherwise, when we talk about 1 optimizer for 2 modules, the modules are connected in series. And you can use this kind of solution for systems above 15 kilowatt inverters. Again, it has 25 years warranty, all the safety functions and things like that. And here you can see which optimizers we offer at the moment. So it's P650 for basically typically two times 60 cell modules. We have a bit higher power range with optimizer P701, yeah, 260 cells or 120 cell PV modules, half cut modules, P730. Here is the special optimizer when you connect the modules in parallel with the dual input. So this is P800P, P801, P850, P950, and I believe there will be soon a bigger optimizer because the module size is getting bigger and bigger. If we look at the design rules, and this can be a typical residential system. For instance, you will do a 30 kilowatt inverter and using some commercial optimizers. So you should know that the minimum of optimizers you will have to have in the system is 14 optimizers. I told you it's 1 to 2 solutions. So one optimizer is taking care for 2 modules. So here should be 28 normally. But we allow always 1 module in the string to be connected with just 1 optimizer. Yeah, it's written here. Please read the notices here. In case of odd number of modules, it's allowed that you connect 1 optimizer to 1 module. It's possible. So here we require 14 optimizers, but just 27 modules as a minimum. And the maximum is 30 optimizers or 60 modules. And the power of the string can be different. And there are some exceptions. Standard number is that you can do maximum 11.25. But in some cases, and it's related to DC-AC oversizing of the inverter, and we will talk about it later, you can do even longer strings. You don't have to think about it so much if you are using a program designer, because this program can allow you to do these strings longer because it calculates even with the maximum DC achieved power. That means that the program calculates how the modules are located, in which orientation, inclination, etc. And it calculates the maximum DC power based on these kind of conditions. So sometimes it can even be above these rules, which I called STC. So if you are using Designer, please be aware the design is approved, even though maybe it cannot match these rules you can see on the datasheet. So when using Designer, you are absolutely okay to do the system. If Designer approves, everything is fine. Let's talk about the products. As I mentioned, we have a residential three-phase systems. These inverters starting from 3 kilowatt to 12.5 kilowatt, but not all the inverters are certified for all countries. We will introduce even now new inverters next year, which will be more flexible. I told you need a minimum of 16 optimizers at the moment for a three-phase residential system. But with the new inverter, it should be more flexible. So the minimum of optimizers can be lower, maybe 8, maybe 10 modules. We will see in a few months once we will introduce this flexible three-phase inverter into the market. At the moment, we offer these inverters, this solution. As I said, the standard inverter technology, but the inverter is very lightweight. It's only doing the DC-AC conversion. It has 12 years warranty. It provides many communication options, Wi-Fi, Zigbee, cellular, Ethernet, of course. and it has quite nice efficiency, and it can be installed outdoor and indoor, of course. We have even inverters compatible with the batteries. I don't want to talk about them today. Yesterday there was a session with Jason, and I think he introduced it a bit more. So if you are interested, please ask SolarEdge to provide you with the webinar link where you can get more information about this new storage inverter with compatible with the BYD or LG Chem batteries. I just want you to know that we have such solution, and I believe there will be some changes once our own battery comes to the market. It will be a bit better solution, but of course we will not stop the cooperation with these great vendors like LG Chem or BYD. Three-phase commercial inverters, I think this is something a little bit more interesting for you. As I mentioned, your limit for resi installation is up to 30 kilowatt. So far, we had only the solution with 27.6 kilowatt. I think the basic features of the inverters are the same like with resi. 12 years warranty, very efficient, very lightweight. Easy commissioning. You can see here is no display anymore. We will talk about it later on. It can have some other flavors like a safety box underneath of the inverter. It provides the safety functions and things like that. But we are coming and there are some first inverters in Ukraine already. And these are in the range of 30 or 33 kilowatt. We have even 40 kilowatt version, but this is for the grids with the voltage of 480 volts. So if you are using a transformer, it can be used for bigger projects, but simply, I believe for you, the 30 kilowatt version will be the most interesting one. What are the benefits of these new versions? So first of all, they are much lighter. The 30 kilowatt version has about 32 kilograms. Before the similar size with 27.6 was maybe more than 40 kilograms. So it's you know, lighter and easy to handle. With these inverters, we can do 150% DC oversizing. We will talk about DC AC oversizing a bit later on. Before it was allowed only to do 135, but with this version you can do 150. We will talk about it, as I said, later on, why it's good, why it's not good, why this can be used in some cases. These new inverters, they have DC surge protection integrated as a standard, but there are some optional products like AC surge protections to be mounted, and also the protection of the communication, especially the RS485 bus. The inverters are of course bigger, so we have a wider AC gland. We have reduced the requirements for the residual current device. Before it was 300 milliamps, now it's only 100 milliamps. This is not related maybe to Ukraine, but in some countries they have an IT grid, only 3 wires. So this inverter supports even 3 wires connection. And the last maybe quite important thing is that these inverters are the first one to be ready for our new commercial battery, which comes next year. It will be 40 kilowatt hour battery made of racks, so you can define the power, the kilowatt hours actually. And you will be able to connect up to 3 these kind of batteries to one inverter, so 120 kilowatt hours can be connected to one inverter. Well, we can talk a lot about the flavors. I will skip maybe to another slide when you can show all or see all the versions all together. And it's actually this slide. So you can choose one of these 4 versions at the moment. On the left side, you can see the basic version when you have DC surge protection or voltage protection integrated and MC4. But there are some other versions needed in some countries. For instance, this last version, which includes the AC surge protection, DC SPD, DC switch, MC4, and so-called AC-DC separation is typically used in France. The other versions can have even, for instance, rapid shutdown function. As I mentioned before, it's used in US, but if somebody really focuses on the safety and wants to have it according to US standards, we can buy this version and can have, the self voltage within 30 seconds. Again, if you are interested more in this inverters, how to install it, then you can watch the webinar provided yesterday by Jason. Here is just the conclusion of all the benefits. And what you should know that we are removing the 27.6 kilowatt inverter from the price list, and we are not producing this anymore because we don't want to have too many inverter sizes. So 25K will be a bit improved and stays, and then we will have 30 kilowatt and 33 kilowatt inverter. Again, allows us 150%. DC AC oversizing, it can be equipped with the AC overvoltage protection. DC overprotection is already inside. It supports some different grids like IT grid. It's much lighter and it has better resistance to DC isolation faults as a standard. There is, by the way, a very nice movie on YouTube how to install it. I thought I had it somewhere here, maybe not. But anyway, I will show you where to find the movies, and you will find a lot of useful movies how to install our inverters or our other equipment. It's done step by step, so it's very easy to understand the process. If we shall talk about the bigger inverters, we call them synergy inverters, and you can find them in the range of 55 kilowatt or 82.8 kilowatt. Basically, you can see this 82.8 is based on 3 units, 27.6. So 3 times 27.6 is 82.8. And obviously, when we stop to sell 27.6, then these 3 units will be 33 kilowatt, and this synergy inverter will become 100 kilowatt version in the future. So at the moment, 82.8. At the beginning of 2021, it will be 100 kilowatt inverter for 400 volt grid. The same story with the 55 kilowatt inverter. You can see these are 2 units of 27.6, so altogether 55 kilowatt. And this is gonna be changed. We can talk about it for a longer time, but the basic information for you, this synergy technology combines the advantages of bigger central inverters and the string inverters. Why? Because you have only one AC connection, but you have 3 DC units working independently. So if one DC unit is broken, the others are working quite fine. So you have good production, you have savings on the AC connection, and there are some more advantages. At the moment, it looks like that you have one primary unit. which is the middle one with the AC connection here, and 2 secondary units, or 1 secondary unit, depends on the version. In the future, it will be a bit different concept when there will be only a unit which we call Synergy Manager and the Synergy units. It will be much easier for stocking, and there will be many new flavors added to these inverters, PID detection and things like that, but this is maybe for the next webinar. As I mentioned, these new inverters shall come at the beginning of 2021. Before we'll have a break in 3-4 minutes, I just want to inform you about the software we have. We cannot go into details, but many installers are quite confused how many applications we have. And it's really a bit confusing. Last week happened to me that one installer was calling me and telling me that our monitoring application is not working. Was really angry, complaining. And after a few minutes, I realized that he was using the Mapper application for scanning the barcodes, which we will talk about later. So it's really important to know what kind of applications we have and the purpose of the applications. So first one is an application called My SolarEdge. It's an application for homeowners, so for the system owners. It's a monitoring application with many benefits, and the installers can do even some basic, let's say, service things. I don't know how to call it exactly, but for instance, they can, you know, change the Wi-Fi and things like that. So it's a new application, not so old. You can check the inverter status, the visibility, etc. And it's designed really for the homeowners. So when you install a system for the customer, please recommend him to download this My SolarEdge application on his mobile phone. For installers, we have another tools. At the moment, it's a bit older monitoring app. You can see that not all the functions are here, but there will be more functions for the installers. So this function, this monitoring app, which you can find on the Google Play or App Store, is designed for installers. My SolarEdge is for the system owners. Both are monitoring applications. When you can see PV system monitoring, you can control the smart energy devices like the heat, you know, the application, the hardware for heating the water. You can control the EV charging if you have the inverter with EV charger. You can configure the Wi-Fi and things like that. So basic smart applications, one for you as an installer, and the second one for the system owner. And before we go to the other applications, I was told that we shall probably have 45 minutes break. So if it's like that, then let's take a break for a few minutes, and then we can go and continue.
Yeah, Peter, before a break, we have a question from our attendee.
Okay.
Okay. You told that optimizers control the voltage in the string in the system, 750 volts. How it's achieved by optimizers?
Okay, it's a good question. Thank you for the question. But we will have a few slides in the section after the break, where I will show the concept of operation and how the optimizers are exactly working in the string. Mm-hmm. So I will answer, I think, these questions in a few minutes.
And is it mean that the current before optimizers can be different after optimizers?
True. The question is, you know, how is the manage the voltage and the current? Yes, the basic thing here is you have to forget about the modules. Something is coming to the optimizer from the module, but something else, some different voltage and some different current, will go out from the optimizer. The power stays the same. You only play with the voltage and the current. You decrease the voltage, then you need to increase the current. If you decrease the voltage, an opposite. Yeah. So, but as I said, I will explain this in the section related to concept of operation. Even install the inverter almost horizontally. Only this option is available. Please do not do it this way or upside down. In this way, you know, the water can go inside, maybe through the connectors. So please, minimum angle of 10 degrees with the connectors going down. Not sure you can you will use this feature, but there might be some roofs with limited space or some rooms with limited space, so could be useful in some installations.
And now let's remove the front cover of the inverter and make wire connections. The front cover of the inverter is secured to the enclosure by 6 Allen screws. Loosen the screws and gently remove the cover. When removing the cover from the single-phase inverter, loosen the screws and gently tilt the cover downwards.
Okay, so here is just, you know, how to remove the cover. I think there is nothing special on that. 6 Allen screws and gently remove the cover.
Before starting to connect cables, we need to make sure that we use the correct AC cable for each type of inverter. For example, the 3-phase inverter requires a 5-wire cable in a diameter range of 15 to 21 millimeters. Once the front cover is removed, we need to identify the location of the AC terminals within the enclosure. The AC terminals can be found at the lower right-hand side of the box. Before feeding the AC cable through the gland, expose each wire by stripping off 8 millimeters of insulation. Use the label on the AC terminals to connect the corresponding cable wires. 3 wires for the single-phase inverter and 5 for the 3-phase inverter.
Okay, I think this is also quite clear. Here on the left side, we have a 3-phase inverter. On the right side is a single-phase inverter. Again, here is our recommendation for the cabling for the 3-phase inverter. Here is the diameter range from 15 to 21 millimeters. It should be, of course, 5 wires. You should strip off the isolation as recommended here. And then I showed you here on the right side is the AC gland. So you go through this AC gland and connect the wires to the AC terminal as marked here. The same is with single phase inverter, of course, only 3 wires for a single phase. And sometimes please check if there is no ferrite bed. If the ferrite bed, and it's typically for single phase inverters, it's supplied with the inverter, please use the ferrite bed as well before you connect the wires to the AC terminal.
Once the AC cables are safely connected, it's time for connecting the DC cables. Each string has 2 DC cables coming from the PV string on the roof, 1 plus and 1 minus. Before connecting the DC cables to the inverter, double-check safety voltage and polarity of each string. Each PV module adds about 1 volt to the string voltage. Therefore, if we have 8 PV modules on our string, the safety voltage is around 8 volts. If multiple strings are connected in parallel, the safety voltage would be the safety voltage of the longest string. Remember, once the DC cables are connected and the inverter is operating, the voltage on the DC lines is no longer safe.
Well, so this is just recommendation of what you shall do before you activate actually the string and the optimizers. You should take a voltmeter and measure, you know, the voltage. If you would have 8 optimizers on the roof, you should measure something around 8 volts. A little difference is allowed. Depends on the, you know, measuring tolerance of the device. But you should not definitely measure the minus 8 volt as here, because then the polarity is wrong.
A few words about string connection. You can connect more than one string in parallel to the inverter. Connection can be done by either running a pair of cables from each string on the roof down to the DC inputs of the inverter, or by creating a parallel connection, using a connection box on the roof and running cables with larger cross-section down to the inverter. You can also use a mechanical disconnect switch or an overvoltage protection unit before the inverter.
Well, this is just about some tips for a DC connection. As I told you, you can create the strings of unequal length and you can connect them in parallel in front of the inverter using a combiner box, or you can add also the all voltage protection. Of course, in the new version, the overvoltage surge protection will be integrated in this 30 kilowatt models. It's integrated already inside. But you can use the combiner boxes when you have projects on the roof, for instance. Then you can have one combiner box on the roof. Then you go with one pair of cable directly to the inverter or to another combiner box in front of the inverter, and you can save money on the cabling. Yeah, it's again a topic maybe for another webinar where we can talk about the bigger projects and advantages of having optimizers and the losses, because as I told you, we have a fixed voltage of 750 volts, and if we have a longer distance between the inverter and the optimizer, the optimizers can increase the voltage, for instance, up to 780 volts here, to have again 750 volts by the inverter. But again, it's more or less for commercial projects, and if you are interested, I can provide you with some more information later.
Let's start off by reminding you that SolarEdge inverters are actually open. Hi, I'm George. The inverter configuration method depends on the inverter type. Majority of SolarEdge inverters are configured via the SetApp smartphone application, enabling inverter configuration directly from the palm of your hand. Whereas SolarEdge inverters with a LCD screen are configured via the LCD and push buttons.
I skipped 2 slides, but there was a movie I showed you already on the YouTube channel where you can see how to install, the inverters. Here is just a reminder that our older versions of inverters were with the display, and the commissioning was done through the display. But as the new inverters are without the display, because display was a bit problematic component, then all the new inverters are commissioned through our setup application and your smartphone.
SetApp supports activation, firmware upgrades, commissioning and viewing of inverter status. The app connects to the inverter by direct local Wi-Fi, so no internet connection or external Wi-Fi infrastructure is required. SetApp automatically updates your mobile device with the latest inverter firmware version before starting inverter activation. To use SetApp, you need to have a phone or tablet running Android 5.0 Lollipop or higher, or iOS 10 or higher with internet connection.
We talked about the setup application a few slides before. But maybe a good thing to remind you is that whenever you have an internet connection and you open the application downloads the latest firmware. So when you are going to commission a new site, you always have a new firmware ready in your smartphone. For the commissioning, you don't need an internet connection, so internet on site is not necessary. But if I can recommend, whenever you are at your home or on a Wi-Fi, from time to time, please open the app and download the latest firmware, because the application cannot do it automatically because of some rules of App Store and Google. So you have to open the app to download the latest firmware.
Hello, I'm George, and
Okay.
before we start,
I'm not really sure what's going on with the voice, but now we will have a few slides about how to install the power optimizers, and maybe some hints and tips what to do and what not to do. So
before we start the installation, let's talk about the connectors. PV modules and power optimizers must have identical connectors. All SolarEdge power optimizers use MC4 connectors to connect to the PV modules and to create a string. MC4 connectors are single contact electrical connectors commonly used for connecting solar arrays, making wiring much simpler and faster. The MC4 connection is IP67 compliant, providing a waterproof, dustproof, and electrically safe connection. Note that there are two different types of MC4 connectors, positive and negative. The polarities are indicated on the connectors themselves. In addition to MC4 connectors, some power optimizers models are also available with Staubli, Canadian Solar T4, Trina and Amphenol connectors. To ensure that your power optimizers and PV modules use identical connectors, refer to your distributor.
well, basically, you can find many connectors on the market. Our preferred and default connector is MC4, but you can find many module producers using different connectors, like Canadian Solar, Trina, and Q-Cells, and other module producers can have a different connectors. Basically, even if you are connecting the modules, you should use the same connectors all the time. We are providing 25 years warranty and for the optimizer, and we really want to be sure that this will be okay after a few years. So please be careful when you have a module and the typically Chinese producer is claiming that his connector is compatible with MC4. If it's not proved by our R&D, like in case, for instance, Trina, then it's better to change the connector, to change the module, or ask the module supplier to provide you with the right connector. We can also supply optimizers with, for instance, with T4 optimizer for Canadian Solar, or even with TS4. But even some of these optimizers can be used TC4 versus MC4. If our R&D approve, then it's okay. But if there is only some kind of list of some Chinese authority who says, fine, these are compatible with MC4, sorry, but you can be without a warranty, because you never know what's gonna happen after a few years if the connector is not a good quality. We always prefer the MC4 original, if possible.
When planning the installation, consider the following guidelines. It is recommended to mount the power optimizer in a location protected from direct sunlight. Make sure the mounting location cannot be submerged underwater. The power optimizers can be installed in any orientation. To allow heat dissipation, maintain clearance around the power optimizer as follows. 0 millimeters from the back side, 12.7 millimeters from the front sides, 10 millimeters from all other sides. Note that the P860 and M1600 power optimizers must have a bigger clearance distance of 25 millimeters on all sides except for the mounting bracket side. Use M8 or M6 screws and washers to secure the power optimizer and verify firm attachment. The power optimizers are double insulated, so therefore do not require grounding. Mounting the power optimizer directly on the PV module or PV module frame could void the module warranty.
Well, so I will shortly repeat what was just said. There is no preferred position for the optimizer, how it should be installed. There is no up or down or whatever. You can install whenever, wherever you want, but you should not put the optimizer, or you should protect the optimizer from direct sunlight because of the heat, of course, and the lifetime. And it should not be, you know, completely underwater. The optimizer is, of course, double insulated. It doesn't require grounding unless it's required by some local regulation. Typically, the installers are, you know, installing the optimizer on the construction. Please use the M8 or M6 screws or washers. And there is a little change in the clearance area for the optimizer. Before we required 2.5 centimeters from all sides of the optimizer for the air ventilation, but now it's a little bit different. So from the we require 0 millimeter. That is the heat sink. From the front side is 12.7 millimeters, and from all the other side is just 10 millimeters from the back, the upper sides and the lower side.
The physical layout of a PV system provides a bird's eye view of the actual placement of each power optimizer at the site. Mapping the physical location of each component enables accurate module level tracking, quick and easy performance control, site diagnostics, and troubleshooting via the SolarEdge monitoring platform. Peel off the power optimizer's QR code sticker, placing it on the SolarEdge template or on your own drawing.
Well, when you are installing the optimizers, you put them on the roof, and then you would like to see them in the monitoring, as we provide the module level monitoring and the bird eye view on the modules. You need to know where the optimizers are located, and you have two options how to do it. On every optimizer, you can find a QR code, which you can peel off and put on some layout template or on your CAD drawing, that you know where this optimizer with its specific serial number is located. So this is the first way how you can do. If you have a small installation, you can peel off the sticker, put it on the paper, and then once you will create the physical layout in the monitoring, you can use it.
Another option for recording your installation layout is by using the Mapper app on your smartphone to scan the QR code of each power optimizer. The Mapper app is available for download from the Android and iOS app stores.
The second option is to use the software I was talking about before. It's the software called Mapper. So either you create the layout of the modules in the application. It reminds a little bit Excel. You're creating columns and rows in a similar way, or you can transfer from the monitoring and actually first from the designer program, then to monitoring, and from the monitoring you can upload this physical layout already in the application. So you will see how the modules are lying on the roof. And then you go and scan the optimizers on the roof. So it's the second option how you can, you know, how you can find out where the optimizers are located on the roof.
Once site mapping is done, scan your sticker sheet and send it to SolarEdge if it complies with the minimum system size for your region-specific requirements. If you are using the Mapper app, verify correct location of each power optimizer on the layout editor.
Well, if the project is bigger, well, really bigger, and you are using these stickers, It can be quite tricky for you to do it, so we can help you in SolarEdge, and maybe some students can do the layout for you, but it's only valid for really bigger projects, more than 100 kV for sure. Otherwise, you can manage it quite easily, or you can use the mapper application to scan the stickers, and then you just verify the layout in the monitoring.
Power optimizers in a string. Correctly identify the power optimizer inputs and outputs. The power optimizer inputs are the short cables connected directly to the PV module, and the outputs are the long cables connected to the string. Connect the long output cables of the power optimizer in series to form a string. And lastly, verify that all the connectors are firmly inserted and locked.
Well, this was just the basic description, how the optimizer look like. So you can see here is a longer cable. We call it output cable. So this cable you are connecting, you are creating the string between the optimizers. And then we have a short cable, and this cable connects to the PV module. Please be careful here when you are putting the modules in the landscape position, and you don't have, let's say, the module cabling standard of the standard length, because sometimes you can see modules when they have the cable length is just maybe 15 centimeters. It's used for portrait orientation. It's used in Asia, and sometimes you can see these modules in Europe. This should not happen if you buy the modules from, for instance, from SolarEdge, but can happen that some modules can have really short cabling, and then you have a problem to connect, the optimizer to the module. Of course, we have versions of optimizers with longer input cable as well. So if we know we need it, we can supply even with the optimizers with the longer input cable, but we need to know the module and the cable length. Be careful when connecting the string. Please do it really carefully, and verify that the connectors are really firmly inserted and locked.
Install the power optimizer near the PV module. Then connect the PV module to the power optimizer input. You can use extension cables between the power optimizer and the PV module only if the power optimizer has the full prefix in its part number, and if the serial number was assigned from week 42 of 2019, or if it's a M1600 or M2640 power optimizer. Let's pause and recap a few key points before moving on. During the daytime, the output voltage of each power optimizer is 1 volt with negligible current. Power remains safe as long as the power optimizer string is not connected to the inverter or when the inverter is switched off. Connectors are watertight only when firmly inserted and locked. Do not leave them unconnected overnight or in wet conditions such as rain, snow, fog, and dew.
So this is exactly the point I was talking about. If there is a problem and you have a short input cable here for the connection to the module, you can even use the extension cable here. I think we have an application node, and I think it's 8 meters maximum for plus, 8 meters for minus, but better to verify in the application node. But it's valid only for the optimizers produced from week 42 of the year 2019 with the number 4 as a prefix in its product number. So before it was not allowed to do these extensions, now it is allowed, but I would recommend you not to do it. It's useless. It's better to buy the optimizer with the correct cabling. You will not face this problem very often, only when you will have really big modules with the split junction box, for instance, or when the cabling is from the module is very short. here is just, conclusion of basic statements, that before you activate the optimizers in the inverter, they are producing only just 1 volt. So it's safe and some very low current, 200 milliamps or similar. And one hint or tip at the bottom, when you are installing not only optimizers, but even the modules, please, if you expect rainy weather or snow or whatever, do not leave the connectors on the roof, because optimizer is double insulated, but the only way how can go water inside is through the connectors. So do not leave them unconnected. Either use the seals or connect them between each other, and next day continue. But do not leave them unconnected, for instance, overnight.
For commercial installations, 2 PV modules can connect to a single power optimizer. In the upper example, we can see 2 PV modules connect in series to a single power optimizer. In the lower example, we can see a single power optimizer with dedicated inputs for 2 PV modules.
Okay, I mentioned to you before that we have that almost all the commercial optimizers are using the series connection. So the modules are connected in series and then to the optimizer. But there is this optimizer P800P, where or maybe even one residential P405, when you have more inputs, so you can connect the module in parallel.
After linking the power optimizer's connectors to form a string, ensure that all power optimizer's cables are properly routed. Make sure to tie all cables to the mounting rails to avoid loose cables. It is recommended to use UV-protected cable ties.
Well, this is perhaps something you know, that you should not leave cables flying in the wind, because after some months or years you will see the result of really damaged installations. It can be very dangerous to do these installations like this. So please don't do that like on the picture on the right, and maybe use the UV protected cable ties as well, to fix the strings, the cables.
After linking the power optimizer's connectors to form a string, ensure, and now
Here, you can, I just found this slide yesterday. It's maybe a few tips what not to do. Look at the optimizer here and how the cable is stressed in this installation. Please be aware there is a connection inside the optimizer. So if you put too much stress on the cabling here, as every connection, it can have some problems. Some problems can occur later on. So please do not stress the cables too much. Here is an example of open connector. So it's not really firmly connected, and this is the case of electric arcs in standard installations. You maybe heard about the Tesla installations in US, and I don't know what was the real problem of so many fires on the Walmart stores, but one of the reasons was just unproperly connected connectors. And here on the last picture, showing the ground fault, you can see that the insulation of the cable will be probably damaged by the optimizer, and of course it's connected to the frame of the modular construction.
And now it's time to verify that all connections are made properly. starting, make sure that all PV modules are exposed to sunlight. Connect a voltmeter with an accuracy of at least 0.1 volts to the two-string cables, read the voltage and check the correct polarity. Each power optimizer should add 1 volt DC to the total string voltage. Note that slight voltage offset might occur during reading. If you have more than one string, verify each string individually before proceeding.
Something we have seen before already, as I mentioned, before you connect the optimizers to the inverter, check the polarity, check the voltage, check if you really have the required number of optimizers. If you have 8 optimizers, you should measure about 8 volts. There could be, as I said, a little bit measurement accuracy allowed, so 0.1 volt. But if you see 9 volts instead of 8, then you have a problem. There is a special presentations about troubleshooting and about some situations which can happen in real practice if you for instance do wrong polarity, if you connect more than required optimizers, if you forgot to connect some optimizer. We will provide you with these presentations and you can check the pictures.
Assemble extension cables with MC4 connectors to run the string to the inverter location, but don't connect to the inverter yet. Make sure to crimp connectors with correct polarity at the end of each cable. Note that cutting the power optimizer's input or output connectors is prohibited and will void its warranty. The combined length of all extension cables should not be more than 300 meters. 2 150-meter cables can be used. Longer distances up to 700 meters or up to 2 350-meter cables can be used from SE25K inverter and above.
So, just shortly, please do not crimp or do not cut the power optimizers inputs or output connectors. Do not crimp other connectors, otherwise you are out of warranty. This is the first notice from this slide. And the second is, if you are using for instance, the extension cables between the optimizers, between the rows, so all this, and the home run cables, of course, to the inverter. So the length should not be longer than 300 meters for the smaller inverters. And if you are using the inverters above 25 kilowatt, then this additional red cabling should not be longer than 700 meters.
Pairing the power optimizers to the inverter is required during commissioning. Pairing is also required when adding or replacing the power optimizer. The inverter uses the SetApp smartphone app to recognize and communicate with the string power optimizers. To start the pairing process, do the following. From the SetApp commissioning screen, select Pairing, and then tap Start Pairing. Note that the pairing process takes several minutes. When pairing is done, pairing complete is displayed. And that's it. Now you know how to install SolarEdge power optimizers.
Okay, so I told you that before we activate the optimizers in the inverter, they are producing the safe voltage, 1 volt. This activation we can call the pairing. Once you will do the commissioning with the setup application, so you will connect the smartphone to your to the inverter, and it will upload the firmware and whatever. There are more steps, but it's really intuitive process, and it will guide you through. In the end, you will see this screen here with several items. So the first one will be the country and language. So you just take Ukraine here or any other country you are in. And then if you want to activate the optimizers and start the production, you need to do so-called pairing. That means if you press the button here and start the pairing, then the inverter will start to communicate with all the optimizers. It can take several minutes, and once the pairing is completed and the inverter finds all the optimizers, then the production will start.
Let's start off by reminding you that SolarEdge inverters are actually only responsible.
Well, this is the additional slide I put there. I would say very similar presentation. We even with George and his description, you can find if you visit our online training. It's very easy to visit it, and I will show you how. Here are some links which we can share with you later on, but you can do it even on your own, and it's really easy. All you need for some of our services is SolarEdge account. So all you have to do, if you don't have our account yet, is to go to our SolarEdge.com website, and here on the top you see the icon login. If you click on the login, you have you know, an option to go to several services we are providing. For some of them, you need the monitoring account. It's actually for the monitoring. So if you want to monitor and install the systems, once you are creating the account, it will require a serial number of the inverter or any other component needed that you can use the monitoring. But if you want to use only our online services, and I'm talking about Edge Academy, so e-learning, where are different courses with the certificate, or when you want to use, for instance, our designer program, you only need the basic SolarEdge account. If I click on it, I'm already logged in probably, so it will not require my login data, but normally it would ask for the login data for you, and then once you use your email and the password, you get in. We will go to designer, and I will show you how to do, or maybe give you some little introduction of the designer program and how to do a little residential installation in a few minutes. But at the moment, I wanted to show you the e-learning. So if you click on login and go to Edge Academy, then you will see a very similar environment. It will be welcome for you, and there will be your courses in a catalog. And here, for instance, I started to do a new fundamental training. So if I click on it, you will see very similar presentations and tips and quizzes and questions. So it's very interactive fundamental training you can go through. I didn't finish yet, but once I finish, there is probably some kind of certification test. And once, if you do it, then you will receive a certificate from SolarEdge. It is valid for the basic fundamental, but even for the advanced training. This advanced training will be a bit reworked or changed a little bit in a few months, but the link is available, so I can share with you. Last but not least, if you are not receiving our newsletter, please do that, because again, maybe I can show you the latest one. We are really informing about the news of optimizers, inverters, designer program, many things like that. Just a second. I do apologize, but I lost a bit. Okay. So here is the last newsletter. If you just subscribe on our webpage, you can get this kind of information, the news, for instance, that the application My SolarEdge is now compatible with the Apple Watch, so you can see the production on Apple Watch. Here is the information about the fundamental training, which I just showed you, that you can get a certificate once you enter. That we have improved the 950 optimizer. Here is the recommendation to see the new movies, the new three-phase inverter, the 30K inverter, how to do commercial design, for instance. We have some new products for residential, like wireless gateway, and things like that. So I would really recommend, to join our newsletter to get the latest news.
Let's start off.
Okay, I do apologize for the noise and the voice, but we went through the basic installation of inverter and the optimizers, and now let's go quickly to the design rules again, and let's do one installation, one resi installation in the designer program. So if I should be brief, then it's a big difference when you are designing the standard inverter and the SolarEdge technology. When you have a standard inverter, you have always to calculate, the maximum input voltage by the low temperatures. You need to always, have modules in the same orientation, in the same tilt. Well, sometimes you can use more MPP trackers, but anyway, the design is very limited. This is something what SolarEdge overcome, and I already showed you the STC design rules on the data sheets before. So basically, what you need to remember is to first of all have the right module, the right inverter, and the right optimizer. If you don't know how to check if this optimizer is compatible with this module, please use always the designer program. When there is a database of modules, and this will always tell you if your module is compatible with this with the optimizer. If the module is missing in the database, I will show you how to add the module into the database. As I told you, some optimizers are residential, so these are one-to-one, and some of them are commercial, when one optimizer can take about 2 modules. The same is with inverters. Some are for residential installations and some are dedicated to commercial installations. If you, from some reason, do not want to use the designer, you can even check the compatibility manually. Basically, what you have to do, you need to take a module datasheet and then compare with the characteristics for the optimizer datasheet. So every optimizer has some characteristic, maximum DC power allowed, maximum input voltage, maximum input current for the optimizer, etc. But please be aware, we are not calculating the STC values. For instance, here you have a maximum input voltage, 48 volts, and the voltage here is 38.1. But this voltage is measured in the laboratory in STC conditions. So you need to check the temperature coefficient, how the voltage is changing with the temperature, and check your location, because you can have -30, -40 in your location. So in this example, you know that you have a minus 30 degrees, the lowest temperature in the region. The temperature coefficient is here. So you see it can be 99.9% more voltage compared to the open circuit voltage. So as I said, you can calculate this manually and check the compatibility between the module and the optimizer, but it makes no sense because the designer will help you to find it out very quickly. In some cases, I told you that we have optimizers, residential optimizers, when you can have one module for one optimizer. But in some cases, even for residential optimizers, you can have one optimizer even for two modules. But I don't want to spend a lot of time with that. You can check the slides. For instance, here you can see you have two modules with the power of 185 watt. With the lowest voltage 34.4 volt, and the current is 8.4 amps. If you take two modules, then 2 times 185 is about 370 watt. So it's okay because the limit here is 405 watt. If you have modules connected in series, then you have double the voltage. That means 2 times 34 volt is 68.8 volt here. And if you have series connection, then the current stays the same, so it's 4.8. So if you look at the optimizer data sheet, everything is fine. And you can connect 2 of these modules to one optimizer. You cannot connect them in parallel because in parallel means that you have 2 times the current, and this is out of the limit of the optimizer. So could be another example with the thin film module when you can connect 2 thin film modules in parallel. But this is something you can go through the slides later on if you're really interested and do it manually. But in my opinion, it makes no sense. But what is good to know when you are designing the system? I told you that we have some minimum number of optimizers or modules for the operation of the inverter. So that the inverter can start, it requires some voltage. And I told you in the single phase system, for instance, in the case of optimizer P300, that the minimum is 8. But look at the picture here. You can see the modules are on the east and on the west, and the inclination or the tilt of the roof is quite high. So what's going to happen if you have the minimum in 2 orientations? The system will work, but of course, when the sun is a little bit more up on the sky. In the morning hours or in the evening hours, when the sun is illuminating only the west side, it has only 4 optimizers or 4 modules, and 4 times 60 volt or 4 times 85 volt is not enough to start the operation of the inverter. So again, the system will work, but not 100%. So what I would recommend is always to, if possible, to put the minimum of optimizers or modules on one orientation, and then you can do a very long strings and put the modules in other orientations. Okay, this is the situation which can happen if you have half of the string dead or shaded, or in really not illuminated by sun. Then of course the system will not work because it will not have enough voltage to operate. You can also use third-party design tools like PVSys, independent program from Switzerland. We have application on how to use it. It's a little bit different when you use standard inverters, when you use SolarEdge, so please follow these guidelines. You can use also PVSol, also compatible with SolarEdge. but not sure if it makes sense because they have to pay for these programs, and the designer is for free. Oversizing. I got a lot of questions about the oversizing, why it's good, why to do it, and why people are actually doing it in many cases so high. So what is DC to AC ratio, and what is oversizing? So actually, in some countries, you have a limit for the installation done by kilowatt AC. So it's actually the nominal output power of the inverter. Let's say you have a 10 kilowatt inverter, and this is the limit for the installation. But as we already discussed, if you install the 10 kilowatt modules, probably the inverter will not work not at the full power, but maybe at 6 kilowatt, 7 kilowatt, because 10 kilowatt modules will never give you 10 kilowatt power. Maybe 1 times, 2 times per year, you will have so good conditions that you will reach really 10 kilowatt. So what's typical? People are oversizing DC to AC. So they put more modules then is the output, nominal output of the inverter. And there are some limits for the inverters you can do. If I shall talk about the SolarEdge inverters, then I put here some examples. If you have a standard three-phase residential inverters or a single-phase HD wave inverters, sorry, non-HD wave inverters, the older ones, then the limit was 135%. What does it mean? An example, if you have a 5 kilowatt inverter, you can put 35% more DC power, more modules. So your installation can be up to 6.75 kilowatt when we talk about the peak power of the installation. If we talk about HD wave inverter, we because it's a new technology and new design, you can do up to 155% oversizing. So with the 10 kilowatt inverter, single phase, you can put 15.5 kilowatt of modules to this inverter. With the 30K inverter, for instance, again, you can do up to 150% oversizing. So maximum is 45 kilowatt you can put on the roof, or it's a maximum peak power for this inverter. Of course, sometimes it's good to do it when you have, for instance, different orientations, or the modules are not in a good orientation or tilt. But sometimes you have to calculate also when you do too high oversizing, that in some months, typically in the spring when it's cold and sunny, the modules can produce more energy than the inverter can handle. So obviously we call it the clipping energy or cut it power. That means that you are losing some energy which could be potentially produced by the modules, but the inverter is not able to handle it. If you want to see this cutted or clipped energy, the program designer will calculate it for you. So you will see in the report, if you take the oversizing too big, too high, then you will see the amount of energy you are losing in the specific months because you did this oversizing too big. And you can decide if you want to have it or not. Usually people want to have a lot of energy in the winter time, and in the winter time it's the production is a bit limited, so they really put more modules on the roof to have at least some energy in the winter time, or more energy in the winter time. And in summertime, of course, they are losing a bit energy, but nothing is perfect. Oh, One more comment. Yeah, here it's actually a picture from the old program, not from the designer. It's picture from the site designer, but you can see the clipped energy here. So you have an inverter with 2 strings, and the oversizing is really high, 155%. And here you see that the program is calculating what amount of energy you are losing if you put too much modules on the roof compared to the inverter AC output power. Here is the oversizing only 120%, and you see there is no clipping, no cut-it energy anymore. One thing is to oversize the inverter. I told you 105%, 150%, 135%. But the second thing is the oversizing of the string. So please, if the program do not allow you to do longer strings, please don't do that and create rather 2 strings. At the beginning, I told you the longer string you do is better. This is true, but there are some limits. For single phase, the limit is 5.7 kilowatt. For 3 phase, I told you it's 11.25 kilowatt maximum power per string. In some cases, 13.5 or even 17 kilowatt. But the designer will tell you when it's possible and when not. Designer, we can go through the slides, but I think it's better to go and maybe show you one little example how to do a residential project. So I will try to do it online. But first, I would like to give you a basic introduction of the program. So once you create a SolarEdge account, you will get access to this program, and when you log in, you will see such kind of environment. I'm not working with this program very often, but there are some, I'm usually using it to test the compatibility of the module with the specific optimizer, but you can see your projects on the main screen. Of course, you can filter them, you can sort them by different things, by project name, by project size, owner, whatever, so you can quickly find them. You can also search them here in the search menu, and if you hover over this the project, then on the right side you can see that you can share the project, you can duplicate the project, or you can delete the project. What does it mean, share? If you have this button here, or you can have this button even here below. Sorry, I will just change the pointer. Can you see my screen now, please? Or I'm not sure if you can see my screen. Okay, perfect, thank you. I cannot use the pointer, but anyway, I hope you can see the mouse moving. Good, so you can share the project, you can duplicate. For instance, you create a project here with some kind of modules or without the battery, and you want to keep this project, but then you want to create the same project, but just change the modules or add the battery. So you can easily click on duplicate, and you just create another name, whatever you want, and you will have the same project here. Yeah, so good feature. Share means that you can share the project with your colleague, or you can send it to us for review, or you can send it to anybody else. You just put here the email of the person, You should give him the right, if he can only view the project or even edit the project. So we can, for instance, help you, or somebody else can help you to edit the project. And then you just get the link, you copy the link and send it via email. It looks like that if you click on done, it will be sent to this email, but no, please, you need to copy the link and send it through email. It's not the email service. So please copy the link and send it to respective person. Then, of course, you have your account here when you can change settings. Basically, I don't want to do it, but here are some basic data, units, password, language. Unfortunately, there is no Russian or Ukrainian language, but there are some other languages maybe you can use, but I will keep English. Then you can manage users, you can add users. It's related to your main account in the monitoring, and you can log out, of course. So this is basic overview here, but for you as a beginner, if you didn't use it before, here is a help button, I would say, where you can use the walkthrough function, so it will guide you through the projects. The same I will do in a few seconds, but if you click on this button, it will guide you step by step how to create the projects. There are many application notes for the shortcuts, for instance, for the mouse, how to upload the consumption data, for instance, and things like that. And of course, a lot of movies, how to create 2D or 3D design in this program. So in this help button, you can find a lot of information. If you want to start a new project, here below is a plus button. If you want to do full project, that means you will create the graphical design. You use one of these two buttons. You choose residential or a commercial project. If you want to do just basic without, so you don't want to draw the 3D or 2D model, you just click here, and you will have to put just some basic data, and it will calculate for you the project very quickly and give you some basic report. But today I'm going to do the full project, so including the 2D and 3D design. I decided to use one of my installations where already are the solar modules to make it easy. So let's start. I will click on the plus button here and take residential. I will put there some name, for instance, this one. Then you need to take the address. So I will put there just the name of the village, and it will automatically put me a picture where the village is located. But I know that the system is installed on this house, so just double click, or you can just move this pointer to the exact place. But you can see no modules, very old picture. This is Google service. And I believe in Ukraine, we will have the same issues, that the pictures will be not with a good quality sometimes, and the resolution won't be good. But I will show you how to overcome this in a few minutes. I will just continue with putting the basic data for the project. If you have some weather data, meteorological data, you can use your own. Otherwise, the program will take the nearest weather station and takes the weather data from the database. You can, of course, put your customer name here and the company, whatever. I can do it this way. Then you just need to decide for the project profile. I said it's residential. If I know the consumption, and I know, for instance, in this house, it could be 3,000 kilowatt hours. I can decide if it should be per year, or I can decide for monthly consumption. If I have a real data about the consumption, I can upload this data here. So if I click on it, it will require for me a file, and we have application note how the file should looks like, the Excel file, where you can upload your real consumption data, which is the best. If you have it, great. If not, you can decide for some consumption profile, which is, you know, close to the customer behavior or whatever. So in this case, I know that somebody is working from home there, so I will take the profile of the probable consumption in the house, which looks like this, because the guy is working from home. So choose this profile. Then, of course, when it's different grid, you can change it, but makes no sense. Power factor is also not something you have to work with normally. And then you just click on create. Well, now you see the picture is here, the house is here. I can zoom it with the mouse a little bit, but you know, the resolution is not really nice, and actually it does not correspond to reality. So what I can do, please check the buttons here above. I can use this button, which is called background image. And if I click on it, I can take some picture which I have from other provider or from drone. This would be a really great picture because it's quite detailed, but you can see the angle of the picture is not really good. Yeah, it should be really straightforward angle and not you know, from the front. So even though the resolution, the picture is nice, and you see how the installation looks like in reality, I cannot use it, and I will take another picture which is a bit better and which is from another provider, a local provider. What you have to do here to adjust, you know, the pictures, you need to take these two pins and put it somewhere on the edges of the building. The same you have to do here. And then click on adjust. So here you can see the picture, and you can use the transparency button here to see that it's really combining these two pictures all together. And I like you know, the picture from the other provider, and click on apply. So now I have my own picture, and if I do not have any picture available, I can use the grid view. If I click on grid view, I can start to draw the picture by myself. So I don't need a picture, I can do it in the grid view. So now I have my picture, and I want to start to do the 2D model. So I go here on this button above and easily start to draw the roof. Please use the suggested angles, the right angles from the program, because as I told you, the picture is not really from the from the right angle, sometimes it's a bit, it's not really accurate. So please use the right angles if the program shows you to do it. Here you can see are some inner edges on the house. You can draw it manually, so you can do it, but I will show you another button here, which should recognize the inner edges. Sometimes it works fine. So I click on the button, I go on the roof, and sometimes it's not so accurate. So you can see it has created something, but it's not so accurate. So I will change it a little bit, maybe to do it this way. I hope it will be okay. So now I have, you know, the edges, but I see here 2 chimneys. So I can click on the button here, which is called obstacle, and I can draw some obstacles. Even here is a window, so I will do it. And now I'm happy with the 2D design, and I can go to 3D design. So I click here on the 3D. And again, I can use the mouse to see how does it look like. And I can do the, I can play with the chimney. You can either do it with the mouse, or you can put the height of the chimney here. And the same I can do here. Here I know it's not the chimney, but it's a window, and I can make it flash. So now I have a window on this roof facade. I can change the angle, of course, of the house, either with the mouse, or I can put it here. If I double click on I can increase the height of all the complete building, and I can play really with that model as I wish. You only had to learn a few shortcuts how to work with the mouse. As you can see, we have some modules on the roof already. So I will use even the modules which I have on this house. And once I'm happy with the 3D design, I can go to PV module placement. So I will start to put modules on the roof. So I click on the button. And now I have to start to place the modules. But how shall I know where is the best place to put the modules? You can use the button here, and it will show you the irradiance, the best irradiance. So here you can see will be probably the east. Here is the south, west, and north. It's not absolutely, you know, north, but it's northwest, whatever. But at least you can see where is the best radiation to place the modules. So I decide to start with this. Here is your help to which edge you wanna place the modules. So you click on it, and now I can place the modules on this roof facade. But first I need to decide for the modules. So I click on the PV module here above, and I can start to find or start to look for the modules I have on the roof. In my case, the installation is done with the AU Optronics modules. So I will put the manufacturer here, and now I need to decide for the model. The best is to start with the number. I will put there 670 because this module does not exist. But you can see there is a message for you. Can't find your module. If you don't have the module in the database, you can click on it and you can add here the data from the module datasheet, and you can either use it only for your database, or you can, if you provide us with the link, you can also send it to SolarEdge, and they will add this module in the next database release. But I will find my module. I guess it was about 260 watts, so we can take, for instance, this module. I can check the module specification if it's really correct, and I can even decide for the color. I have blue modules. Very often you can see black modules as well. It is a flash mount installation, so parallel with the roof. But you can, if you're doing commercial or residential project, you can have a construction on the flat roof, or you can use the east-west configuration, whatever. You can also change the azimuth and tilt if you are not using the pictures. And after that, you can also decide if the modules will be located in a portrait position or landscape position. And you can also put the column spacing and row spacing. So I will put just, just for fun, 5 centimeters spacing between the columns. And I know that the modules here are already placed in a portrait position. So I will place them this way. Well, this is too much. So what I can do is just to click on the module, delete, delete, or I can extend it if I want and put the modules everywhere where is no obstacle, and I can really play with that. But I have only 6 modules on this side, so I will delete the other modules. Put them on the place where they are actually located. There is one more thing. If you have some rules that you need to keep some distances, for instance, then you can use even these helping lines, and you can avoid to put modules in some protected areas or whatever. So this is also possible and good tip. And here below you can see how many modules you have and how much power at the moment. So I put 6 modules on this side, and then I want to place modules on the south. So I click on this, double click on this. See, this is not really, I didn't do it properly, but I hope I can place these 4 modules here again. So I put here on the button at PV modules. I can change the modules, or I can keep the same. I have the same modules. I only need to change the landscape because it's in landscape position. So I will put in landscape, and now I can do it. As I said, I was not really perfect when I was doing the design. So yeah, I can do it this way. And then you can see here another 4 or 6 modules, depending on the time. And yeah, I need to change it again to portrait. And put these 4 modules here. So if you look at the entire site, you can see I have modules in 3 orientations: east, south, and west. And now I should do the wiring, the electrical part. So I can go and push the button electrical design. And here I have several options. I can decide if I want to use all types of inverters, or single phase or 3-phase. The installation is quite small. It's about 3.64 kilowatts. So I will use the small single phase inverter. But here I can change the DC oversizing. Normally it would change even the inverter type. Depends on the configuration. I have a question here coming. So Peter, can you show how to put exact size of the roof in a 3D model? That was the question. How you can put the exact size of the roof? Well, the exact size of the roof made from the, let's say, satellite picture is not easy. It won't be absolutely accurate, but I can tell you, if you look at my house, my installation here, then it works quite fine. If you have drawings of the house, you can use the grid view and draw it according to exactly to your documentation. But if you are using the satellite pictures, there might be some little, differences, especially when the angle of the picture is not really, correct. Yeah, but if you have the house which is probably not, for instance, not built yet, you can use the grid view and do it accordingly, do it absolutely accurate with the dimensions of the roof. I hope this answered. If not, we can discuss later. Okay, so I have some kind of oversizing here. I will use a little bit another type of inverter. You can, if you go here, you can decide for another inverter from the list, which will be okay. I have this inverter in this installation, so I will use this one, and you can see that the actual oversizing is 90% because I have it in free orientations, and it calculates the tilt and orientation. And of course, the installation size is 3.46 kilowatt. I can add the battery here. So I can simply click here and add the battery, but I don't want to do it because I don't have a battery at the moment. And now I can decide for an optimizer. It shows me that I can use the P370 optimizer, but in this case, it will be okay because the tilt is very low. The roof does not have very high tilt, and the sun will illuminate almost all the modules quite soon. But if the tilt is really high here, then maybe it's better to use the optimizer P404, which I showed you can increase the voltage a bit higher, and you need only 6 modules to have the required voltage. Yeah, so if you have a short strings, for instance, this P404 optimizers only require 6 optimizers or 6 modules for the operation. So I can leave the optimizer here. I can change the optimizer even here later on. Here above, there is a so-called optimizer tool, and you can change the optimizer even here. So okay, I have my inverter, I have my optimizer, and what I can do is to use either auto string. That means if I click on it, it will create automatically a string here. So the electrical design is done automatically. Or I will not use this tool because in some installations I'm going to do it by myself and click on generate. Then here you will see that I do not have any string ready. So I can click on a string button, and I can press the left button of the mouse, and I can go module by module and create the string. You can see it was red because it was not enough optimizers to create a string. I told you the minimum with P404 optimizers is 6 optimizers. So I'm on number 5 and it's not enough. If I click here, it's already 6 and it's okay. And I can go, and you can see that I can do one long string without any issue. So I have modules in 3 orientations in one string. Once I'm happy with the electrical design, I can go to summary and report. So I can click here on the button and looks what happened. It will create automatically a report for your customer. Of course, you can have the data of the customer here. You can upload your logo, and then you have a picture which you can still, which you can still play with. So you can do whatever you want. You can also have more pictures if you want. So you click on the button here below, and then another 2 pictures will appear. You can show the customer the irradiation, or you can play also here from different angle. You can show the grid view, for instance. How does it look like? So you can customize the pictures. Then, of course, you will have a system overview here. So for this installation, you will need 14 optimizers and 14 modules, 1 inverter, dedicated optimizers. Again, you can play, you can move it down or up. Here are some buttons how to do it. Here is a basic simulation. So the installed power 14 times 260 watt is 3.46 kilowatt. The maximum AC power is just 3.31 kilowatt. So you know the modules are not the optimal orientation, and the maximum production will be 3.31. Then here is the annual energy production, some CO2 emissions saved, and some trees or equivalent of trees planted for your energy saved. Here is some diagram of the system production. So you know that you will produce probably 3.44 megawatt. With this profile we have chosen, so the guy working from home, you will probably self-consume only 37% because you don't have a battery, and the rest you will probably from this production put in the grid. So 2.8 megawatt hours you will export to the grid. If you look at the consumption, we at the beginning we put in the program that the 3,000 kilowatt hours or 3 megawatt hours was the consumption. So self-consumption is 42%, the same like here. And the import, what you have to buy from the utility is 1.74 megawatt hours. Here below you can see the graph showing you the green one is showing you the production. Then the blue one, of course, showing you the self-consumption, and the red one is a consumption. So it's separated by month. If you would do the DC oversizing too big, then you will see the clipped energy. So there will be another column showing you how much energy you lost because you put too much DC modules for the inverter. But in this case, there is no clipping. I'm not cutting the energy. The DC oversizing, DC AC ratio is very, very small. Here you have the basic information about PV modules, peak power, racking type, orientation, azimuth, and tilt, and the total power. So you see 4 modules on one side, 6 modules on the east, 4 modules on the south again. Here is a bill of materials. So if you are creating a report for your customer, you can decide for the currency here, and you can put here the cost of the inverter, of the optimizer, of the module. You can add whatever you want here. So you can put there, I don't know, a smart meter or construction or whatever. And in the report, he can see even the total price. Of course, you don't have to use it. You can have always the option for any part of this report to delete it. So possible, okay. Fine, we have 10 to 15 minutes to finish it, so I will just be a bit more quick. Electrical design, 1 string, as I told you, 1 inverter, 14 optimizers P404. And in the end, we have a system loss diagram, which you can also influence and maybe change a little bit some data here. it's more or less for professionals who really understand AC or DC ohmic losses or whatever. You can change it. Here are the, it's here in advanced settings, and here are some basic simulation parameters. So this is the basic report, but if you want to use it also for the installer, I mean for the people on the roof, you can also download the PDF with the string layout. I'm not sure if I put the button, if you will see still the screen, because it will download the report. I hope you can still, okay, I hope you can still see it, but you can create very nice layout for the people on the roof, how to string the modules on the roof. So this is basically how the program works. As I said, it's online, it's free for use. You can also use the other features of the program. If you are happy with the layout, then you can export it to monitoring. I told you, you click on the button, and then in your monitoring will appear the module layout like we did in the designer. You can also use the share button, so you can share the project with anybody else, as I already showed you before. Okay, so this was quickly about the designer program. We will have some room for questions later on. Anyway, we are by the end of the presentation. I would say maybe it would be good for the new attendees, maybe even to show you a little bit the monitoring, but I'm afraid we don't have enough time, but so I will do it just very, very quickly. So basically, again, when you have the SolarEdge account and you enter the monitoring, you will see similar environment like it's here. You see I'm very big installer who installed 2 installations. And this is the basic overview of my installation fleet. Of course, if you have 10, 15, 20, whatever, you will see them as a list here. You can also check the map and you can see them on the map, yeah, where it's located, etc. But I will go back to the site list. Here above, you have some buttons, so you can see all the sites. You can do reports for all your sites. And you can also contact our tech support if you click on the button here. It will guide you, or it will link you to our webpage. And here you can ask for help our tech support. It's the best way how to do it. You can do it from here, or you can go on our website, and there is also button support. Of course, you can search for the site because and you can put some keywords as a key account, serial number, whatever, name. You can do different filters showing you, for instance, the problems on the installations or whatever. You just need to play a little bit with that. If you want to create a new site, you can use this button here. If you click on it, then it will guide you through the process how to create the site here. I will go to this installation I showed you a few minutes ago. Please ignore the logo and the pictures. It's quite old installation. And at the front page, you can see some dashboard, some basic environment. If you have a smart meter installed, then you can even see what is the production, what you are consuming in your house, and if you are buying some electricity, then you will see even the amount of energy of what you are buying. Here is the production today. Here is the energy this month, and here is the lifetime energy of the site. Of course, here you can upload your logo, put some picture. Here are some basic info about the installation. Where is it located? The peak power. On the right side, you can see also probably the weather on site, some benefits, CO2 savings and things like that. And here are also some power and energy charts, daily, weekly, monthly, etc. You can play with that, and you can compare the energy. As I have a smart meter, I can see the export, self-consumption, import. I have a billing cycle, so I'm selling the energy to the grid. So I can check, I can set up my billing cycle. It's a monthly in this case, but I export it to the grid 15 kilowatt hours, and they will pay me for about 15 kilowatt hours. So I can even check here. It's not really absolutely accurate, but basically it shows what I have exported. Here you can compare even the energy between the years. So you can see 2020, 2019, 2018. You can see the production last year was very good. This year is not so good, but not bad. You can really play with that. You can export, of course, to Excel or any other format. So this is the basic dashboard. Then, because I'm also hitting the power, so if I have enough solar energy and I cover, the TVs and the lights and the fridge in the house, then I can use the excess energy before I put it in the grid and sell it. It's much more efficient not to sell it, at least in Czech. In Ukraine, it can be different, but in Czech Republic, it's better to consume it in the house. So I'm using the electricity to heat my water. So at the moment, you can see I'm heating the boiler with 710 watts. It's actually, I can schedule how it should be done, or if, for instance, it can be used only when I have excess solar power, etc. We don't have time to go, but there are many schedules you can do. Here is a layout. So how does it look like from the bird's eye view? Well, looks like the internet connection is not the best. I can hear you, but yeah. Can you hear me now? Perfect. So I hope it was some temporary. Yes. So here is the layout, how the modules are located, and I can do a lot of stuff here. I can, for instance, play the production daily, for instance, or for today. You can see how that these modules will perform a little bit more at the beginning, and then it gets brighter and brighter. It's just more for fun, this playback. But I can click, for instance, on the icon of the inverter, and I can do some things remotely. I can pair the optimizers remotely. I can reset the inverters. I can do different charts. I can do even to see the device screen. My inverter is still with the display, so if I click here, I should see in a few seconds, but I'm afraid about the internet connection. I should see some data about the AC voltage, power, and things like that. And I'm afraid really the internet connection is not the best, so I will skip this. I can see errors. You can see some islanding trip here. I'm not sure what is this, but probably not serious because it didn't stop the production. running operations, system data. You can check whatever you want here about the grid, about the inverter, about the isolation value, whatever. Quickly to charts. If I click here, I can, for instance, take some modules, or I can do it in from layout. I can take these modules and I can compare, for instance, the energy. If I click here, it will go to charts. It will ask me to allow the Flash player, sorry. By the way, the Adobe Flash will not be supported anymore. So we will change the designer soon, and even the monitoring features a little bit. So this will come soon. Once again, I will take, for instance, these 3 modules, click, right click. By the way, if you go, if you hover over the module, you can see the basic data again. But I will choose the chart energy. It will jump to a chart section, and it will create energy charts for these 3 modules. Yeah, so you can see it's different. And why it's different? Because these 2 modules are located on the south, and this is on the west. So when you are comparing the modules, you should also know the orientation of the modules. You can do whatever you want here: energy, current, optimize the voltage, module voltage, and you can play with really detailed data. Reports. You can create reports about AC energy. You can create a report when you finish the site to give the customer what's installed there, about site status. I told you about the mismatch analysis. So with 2 clicks, you can analyze all the modules and inverters on the site. No need to send people, no need to use drones, no need to use infra cameras, no need to buy any equipment. With this and 2 clicks, generate report, it will show you which modules are maybe not performing well, because it will take the production of at least 30 days of modules, and it will compare the production between each other, and then it will give you some guidance which modules are not performing well, or inverters as well. Alerts. There will be a new system of alerts soon, as I told you. No alert, a very important button, and this button will have only the installer, so not the end customer. I see the internet connection is again a bit weaker. I hope it will be better. Can you see the screen, please? Can you see the? Great. So I will not show all the features we have, but I will give you just one tip, for instance, how to grant the site access. Here you can see I gave access to 2 people. What you have to do, if you want to give monitoring access to the people, you go to admin, you go to site access, you get this, you click on this button, add new user, you just fill in the email, you give him the role, and the role means what the end customer or what the user can see. If I give him full access, then he will see dashboard, layout, chart, reports, alerts, but not the admin. If I give him a dashboard and layout, then he will see only dashboard and layout. If I give him only the dashboard, he will see only the dashboard. So you can decide what rights can be done to the user. Then you can make the installation public. If you click on this button, it creates automatically a link, and anybody can see this. You can put it on your web page, you can send it to anybody, and it will be also on our web page. If you go to monitoring on our web page, below there is a button called public sites. If you click on it, then you will find this installation there, because I made it public. I can also do a kiosk. This is usually for companies. If you, for instance, click here, it will create this link, and I will try to show you what does it do. If I copy and I put it in the browser, it will create such, let's say, simple monitoring, and it's used for many times by companies because they have, for instance, a smart TV in the lobby, and if you have a smart TV, you have a browser. So if you create this simple link, you can put it in the lobby, and then you will have this kind of monitoring on the smart screen, and it refreshes automatically. So there are many more features in the monitoring. You can play with that. You can check our presentation, which is dedicated to monitoring and remote troubleshooting and similar. But we don't have time for this today. So basically, that's it, and probably we can go to some questions.
Peter, I just wrote you a question from one attendee. You can see it in the chat. It's regarding the voltage in the string.
Okay, so I will repeat the question. You said that the voltage in the string is stable, 750 volts. Is it stabilized thanks to current increase on optimizer side? Can the current be different in the string before optimizer and after? Yes, as I already showed you in the slides, in the concept of operation, it's exactly like that. You have some voltage and some current going from the module to the optimizer, and from the optimizer, it can be a different voltage and different current. So there is ongoing communication between the inverter and the optimizers, and they will always decrease or increase the voltage as it needed, that the inverter has 750 volts. And if you increase the voltage, that means you need to decrease the current because the power stays the same. What goes to the optimizers from the module actually goes out from the optimizer as well, but the voltage and the current can be different. Increased voltage means decreased current. So that's basically the principle of how it works, and you can check it again in the presentation. I think once you will go through the slides slowly, then you will understand it fully.
Peter, I see that there are still more couple of questions regarding the designer tool, and it's basically questions are repeating itself. It's about the exact sizing, and I see that customers are claiming that when you draw the roof in 2D model and then try to transform it into 3D model, it doesn't represent the sizes very precisely. I don't know why they need the sizes precisely, but maybe just mention that all the questions regarding the designer tool can be asked to Jason or to you in a private mail. So maybe they will,
Exactly. Exactly. Okay. Okay. Vlado just mentioned that there are still ongoing questions about the sizes, the dimensions in the designer in 2D and 3D model. Honestly, I don't know exactly what is the problem, but the best would be if we can get this question in the email with some further description, and me or Jason, who is a specialist, I would say, for the designer, can answer in a better way. If something doesn't work well, we can also ask the designer team to check if there is any bug in the program. Please be aware, this program is still in the development. We added many new features, and every 2 weeks there is a new feature. And you have to understand, we have new products, and the design rules are changing, the module size are changing. So it's not easy, to have everything 100%. The program works, I would say, very well, but there are some little bugs, and we are happy when the customers tells us something is not absolutely correct, and we would be really happy if you can do that.
Шановні